Jared.
Thank you, sir. Faith, I loved your homework. It was very well detailed.
Oh, thank you.
Ola, your homework was too brief, even though you
Mr. Gerald, sorry, maybe you get back to Ola. The display ports, when I was doing my research on it, the answer you gave me, the HDMI and USB-C, the VGA and DVI, when I was going through it, I found out that those are video adapter ports. But with the question, you asked us to give examples of display ports. So
display ports fall under the category of peripheral ports. So I think you were going more into the way display ports work internally in the machine. But the homework was more about the peripheral ports around the machine. Like, what are the display ports? Like, there are more of like, what ports do your machine display? When you look at the machine physically, what can you see, right? Which will be like your VGA port, your HDMI port, and all the other ports.
Those are more, so those are video display ports. Those are video adapter ports then?
Yes,
like
they
the
all fall
HDMI.
under display ports. Like anything that your machine displays that you can see physically, they fall under display ports. But now, if you go into the details of a display port and how they function, then you get into more details as to how display ports work on a computer.
Okay.
And
thank you very much.
Welcome. But I loved your homework. It was very, very, very well put together. Your definitions, I loved the first definition of what a server is. A lot of people were just jumping and, it was very detailed. And Ola, please add some flesh on the bone. You already have. Your homework is good, but it's too scanty. You need to, I need more stuff. If I was interviewing you and Faith, I'm going to give the job to Faith because she went deep into some stuff. You were just touching and passing, like, So, but overall, great job, everybody. Bismarck, please submit your homework the right way, please. Don't send it to me in Slack. And Emeka, do you have any comments on your homework? I also commented on that.
Oh, no comments.
Okay, nice. So
Hey,
Jarvis.
But a computer port and a peripheral port, are they the same? Because looking at the definition.
Yeah, they're pretty much the same. Like anything in the periphery, right? Periphery of a computer will be peripheral ports, which are kind of still display ports. So it's like learning the IT terminology. It's like I'm asking you the same thing using different terminology just to try to see if you guys will be confused or not. But peripheral ports are the same as display ports, like what the machine displays. But you have to know that not all machines will have the same display ports. Others will have more ports, others will have less ports, But the key thing is to know what kind of port is on the machine and be able to identify a port when you see it. Today, I'm going to make a great distinction between a peripheral port and a network port, because a lot of people were listing network ports, right? Network ports are different from peripheral ports. Network ports are actually different kind of ports, and they are used to do different things. So with that being said, I'll introduce you guys to networking today. We'll do some networking, and I'm going to be going very fast with the assumption that you guys watch the videos. If you didn't watch the videos, then you will slow us down. You will slow us down. So I don't want anyone to slow us down. But again, if you don't understand anything, stop me, ask your question, and I'll explain it to you. So I'm going to be starting networking today at a high level, and then
quick question. Did any of us actually watch the video? I didn't watch the video, I'll confess. I started, but I didn't finish.
Yes, please do. It's very, very important. Look, there are a lot of things that you gain from there that I cannot explain everything in this class. I cannot explain everything, right? There are some things that I expect you to go get from there. And if you have a question, you bring and I'll answer. And some things, while we the tutors tutor, it comes as we're doing the tutoring. You know, sometimes I can't remember everything. I want to tell you just the important things you need to know. But again, for me to be able to communicate that important stuff for you, I need to get some feedback. I need to know that we are on the same page. So please make time, even if you take an hour. Most of the videos are like 5 minutes, 10 minutes. With 2 hours, you can brush all those videos. You can watch the first 20 videos in like 2 hours. So take some time and watch them. It's very important. So we'll do some networking today. Like I said, I'll introduce you to networking at a very high level. But there are some things that I will really expect you to do, understand. And next week, Charles is going to come in and go more detail.
Senior Gerard.
Yes.
Please, so are we done with the Windows stuff?
No. Networking is, we are moving into a level of Windows where you need networking. And for us to move to that level, we have to cover some aspects of networking before we can cover those topics, because we don't want to put the cart before the horse, right? I don't want to be explaining things to you and you guys are looking at me like, okay, what is this guy talking about? You know, and what you need to know about networking is that networking is a top level IT skill. No matter where you find yourself in the IT environment, the environment where you find yourself doesn't matter. You need to understand networking. To be a Windows admin, to be a Linux admin, to be an AWS engineer, you need to understand networking. If you don't understand networking, you are in big trouble. So I just want to emphasize that. So if you want to slack on anything, let's say you want to slack on the hardware stuff that we're doing, you don't have time to go watch the videos. Networking is not that part that you want to ignore. No way. Because your server will not connect to the network, and you will not come and call me and say, Gerald, my server is not connecting. Come and help me. I will not come and help you if you. So please, networking is as important as, I don't know. Like you can't escape from networking, unless you want to become a developer. That the only thing you're doing is writing code. You're not dealing with any system support. You're not building infrastructure. You're just writing code. Then you're gonna be free from networking. If you are doing something like analytics, things like that, that got nothing to do with the overall functionality of the platform, then you can escape networking. Other than that, there's no way out. You manage servers, you manage infrastructure in a hybrid or cloud environment. Networking is a must. And it's not just about understanding networking, it's about troubleshooting networking issues and fixing them. It could range from network connectivity issues to why my router is not routing internet to my machine, to my network interface card is down, my Wi-Fi signal is down, all those things. I'm not getting an IP address on my machine. It all covers networking, and you need to understand them. The thing with IT is understanding the concepts is not really a problem, as I've been able to determine. It is applying the concepts that become a problem. Like yesterday, we all knew about hardware stuff, how we could, change RAM and swap disk. But when I asked you guys a technical question at the end of the class, now applying the knowledge now became difficult. Like, okay, I've been given a machine that is broken. How do I fix it? Okay, it becomes hard, right? That is the thing with IT in general, is the application. How do you use this knowledge and apply it in a real life scenario? So like I said, I'll introduce you to networking at a high level, and then Charles will come in. But I want by next week, Saturday, when Charles is coming in, you guys should already be familiar with a lot of stuff. So let's dive into it, unless someone got a question. Okay, no question. Nice. It seems we're gonna have a fast class today.
We are ready. That's the only question we have.
Okay, guys, put on your seatbelts. We're about to take off. What am I sharing with you? Okay, I'm gonna share this with you. Okay. And I'm gonna share this document with you at the end of the class. I'm gonna put in the notes so you can all have it. Okay, so introduction to networking. So here is a brief definition of what networking is all about. The story of how computers are linked together to share data or information. So the main reason why I'm able to communicate with you, you're able to communicate with me, is because our computers are linked together. The main purpose of computers linking together is because they want to share information. That is what the internet is all about. Computers that are linked together to share data or information. That is what networking is all about. So if you hear about computers in a network, it simply means you've grouped together computers and try to make that computers communicate with each other. We can have 10 computers in this room right now, in my room, and those computers are not communicating with each other, then that is not a network. So if you come into my house today and you ask me, what is my Wi-Fi password, right? And I give you my Wi-Fi password and you connect and get internet, what is actually happening is your device or your phone, whichever device you're using to get internet in my network, is being joined into my network. It's being connected to my network. That's what creates the chain, right? And when you connect to the network and you start surfing the net, or you go on social media and you're doing something, the device you're using is actually exchanging information with whatever server you are connecting to. Remember, I told you guys in the previous class that each time you connect into the internet, or you're going to a website, Facebook, Amazon, whatever website it is, you are making a connection with a server somewhere. Facebook is sitting on a server. Amazon is sitting on a server. Slack is sitting on a server. All these websites are sitting on a server. And for you to actually go to a web browser and type www to get the web page loaded to you, your machine is making a communication with that server. You are communicating with that server. And at that point, your machine becomes what is known as a client. It could be a phone. When I say machine, it could be a laptop, it could be a desktop, it could be a phone, whatever device you're using to connect to the internet, right? Let's use Facebook since it's a popular social media platform. You're connecting to Facebook and you type facebook.com. All you're interested in as the user is that Facebook page. What happens in the background before the page loads is none of your business. But in this class, we have to be able to explain what happens in the background before you see that Facebook page. So if the Facebook page doesn't load, you should be able to tell, okay, what is, I can tell that the Facebook page is not loading because it's a 404 error. What does a 404 error mean? It means my device is not hitting the Facebook server. It is hitting the Facebook server, and the Facebook server is responding to my device with an error. Is the error coming from my side or is coming from the Facebook side? You should be able to tell by the time we're done with networking. So when you go somewhere, Jeff J, and people say, hey, we have a network issue, just say, bring it, I'll take care of it for you. So networking is all about communication. Like think of us, we're in class right now, and we are building a network of IT professionals, right? We're a network, we're a team. That is what networking is. You group computers together for the sake of sharing information or data. That is what networking is all about. And the more you add devices in that network, the network keeps growing, right? And at some point, it's gonna go out of the space that you are into another space, like from my building to the next building. That's how networks continue to grow. Now, here's another thing you should also understand. Let's talk about network devices or network devices. Yeah, network devices. Devices that you use in a network in order to communicate in a network. You have laptops, you have desktops, you have servers, you have routers, you have switches, smartphones, tablets, cameras, anything that can connect to the internet. Any device that can connect to the internet is part of a network device. You can regard it as a network device. So that is a brief definition of a computer network. Now, let's talk about open and closed system. So if you have a computer at home or any device that is not connected to the network and is not communicating with any other device, then that system is known as a closed system. So when I talk about system here, I'm referring to a device. So if you have any device that is not connected to your network, so you have a laptop line somewhere at home, but the laptop is on, but you haven't connected that laptop to the internet, that laptop will be considered a closed system because it's not part of the network and it's not ready to communicate and it's not communicating with any other device. An open system is the opposite of a closed system, okay, which is simply any device in the network that is ready to communicate with other devices. So you have a device that you connect to your network that is actually communicating with other devices, makes that device an open system. Any question about that? No question. We move on. Okay, now let's scroll down. I want you to pay attention to this word here, host, right? Because you hear about host a lot. So each time you hear about host, you should know we are talking about a computer device. The device could be a physical device or it can be a virtual server. So when you start virtualizing and building virtual machines, those machines will be known as hosts, right? And host can also, like I said, a host could be physical or virtual. A virtual host can also be part of a network, same as a physical machine or a physical device. So a computer network is not only for physical machines. You can also build virtual machines and add those virtual machines to the network, which is what we're going to be doing. We'll build our virtual machines and connect our virtual machines to the internet. So we can go to the internet and communicate with other devices with our virtual machines, you know. So devices in network terminology are regarded as hosts. So if you hear me talking about a host, just know I'm talking about some device, some network device. It could be a laptop, it could be a desktop, it could be a palm top, whatever device it is, or it could be a virtual machine. Okay. Now let's talk about network topologies. So a network topology is simply the way.
I have a question.
Go ahead, please.
Okay, I see that on your definition, host is capitalized. Is there a meaning behind it being capitalized?
I didn't hear you well. Can you come again?
Okay, on your definition, I see that host is capitalized. Is there a reason behind all of it being capitalized?
The reason behind capitalizing host here is just for you to pay attention. Because if I put it in lower caps, maybe you will not pay attention to it. So I want you to really pay attention to the word host. But it doesn't mean that when you start using the word or coming across it, it's going to be in caps. It's going to be in lower caps, lowercase. But when you see it, no, it's the host I was emphasizing about. So let's talk about network topologies.
Now, Gerard.
Yes.
So the host, is it only for, let's say, computer servers that are host, or clients devices can also be called host?
Client devices can also be called host. Like, look at what an interconnection of multiple devices. So multiple devices. The keyword here is devices. Is also known as host, right? So host with an S here tells you that it's not just one device. If I visit you, I come to your house and I tell you, okay, please, I want to connect to your internet. What's your Wi-Fi name and password? And I connect to your internet. My machine becomes a host in that network. Understood?
Yes.
Okay, nice. So let's talk about computer topologies, network topology, sorry. Topology in networking is simply how the devices in the network, within the network, are placed. Every environment will have a different topology. So when you start working as an IT professional, the first thing you want to ask when you get your first job is, you want to understand the network topology in that environment. And when I say the way the devices are placed, I'm not talking about putting one device here and then putting one downstairs and then putting another one upstairs. That's not what I mean, right? The topology got more to do with how are the devices connected within the network? Are they connected in the bus format? Are they connected in the star format? Is it the mesh where all the devices are just connected like in the mesh format? Or is it a ring where you have one cable that connects everything in the ring? So that is what the topologies are all about. And different topologies will have their advantages and disadvantages, right? So let me just show you a picture of what the topologies will look like. Okay, so let me pick any random picture here. Now, this is what I'm talking about when it comes to topology. See, so one of the topologies here is a ring. This is what I'm talking about. Like, they are placing the devices in a ring format, such that this could be like the main computer that brings in internet into that network, and then it's connected to this, to this, to this, and then it all goes around back to this computer. That's what a ring topology will be. Like I said, every company will implement a different kind of topology, and there will be a reason why they're implementing that topology. Each network topology comes with the advantage and its disadvantage. Now, let's look at a ring topology, for example. Look at this diagram right here. We have one computer here, and the connection goes all the way around. All the computers are connected to a ring, in a ring format. So let's take a scissors, right? And we cut the connection from here. Let's cut this connection from here. What happens?
Network has failed.
Gerard, we can't see the cursor moving.
You can't see my cursor moving?
Can you move the picture to the left side? It's too much to the right.
I can't move it because
Oh.
Yeah. So okay, look at the picture with the ring network topology. Can you see that?
Yeah, I can actually move mine. So
I think if you shift your view.
Yeah, that's what I just did.
You can see the picture fully.
Okay, let's do that. I think this one is even smaller. Let's see. Yep. We'll go back to this one.
I was meaning for us, like for we who are doing the lesson, if we just shift our, like the where we see the faces and everything, if we just shift it to maybe the left side.
I moved the
thing
zoom
is,
to the left side.
Yes.
I can't, for some
can
reason,
see
I
it
can't
now.
move it.
Yeah,
on my side.
I can see it now, Mr.
I think
Gerald.
we can see it now, Gerald.
Okay.
Yes.
So now let's say company is going with a ring topology, for example, right? There are advantages and disadvantages of any topology that you implement. Like look at the ring topology, for example. You have one machine, all the machines are interconnected in a ring, which means that if there is a disconnection between these, if there is a disconnection between, for example, this machine and this machine, these two machines will not be able to communicate. Let's say there is a cutoff here. If you take a scissors and you cut this connection between these two guys here, this machine will be only able to connect to this guy. The connection between these two guys will fail, right? Similarly, if there's a cutoff here, this machine will be unable to connect to this guy. But the machine will be able to connect to this guy, who is connected to this guy, who is connected to this other guy, right? So the connection will only be able to go one way. It won't be able to go this way because this guy is cut off. Okay, let's come to a bus topology. This is a bus topology. You have a straight line and then you have switches that connects. So think of the line in the middle as the main network that comes into that office. And then all the machines are connected to that network from here to get the internet connection, right? Bring your scissors right here and cut it right here. What happens? The entire network fails, right? So that's the disadvantage of a bus topology. Because if the network breaks here, everything behind fails. The entire network goes down. So if you're implementing this network, you should be aware of something like this. If something like this happens, your network is going to go down. So that's something you should be thinking about. Now, let's look at the fully connected network topology. That is like a ring, it's like a bus, like everything is interconnected. Like if this guy, if the connection between this guy and this guy fails, right? This guy will be able to connect to this guy by going through this guy and still connecting to this guy, rather than going all the way around to connect to him, right? But the thing with this network right now is going to be hard to manage because there's a lot of interconnection. This network is good, but to manage a network like this, you will need a team of highly qualified experts who are network engineers to support this kind of network. It's complicated. You know, so if you want to do a fully connected network topology, be ready to put together a highly functional team who are very, very detailed in what they're doing. Now, let's go to a star. A star topology is what I have in my environment right now. We use a star topology. We have a switch in the middle, and switches are usually connected to routers, and routers connect to the internet. So the router sits at the edge of the network, and I know I'm mentioning routers. A router is just a device. I'll talk more about it. So the router brings the connection to the network and then connects to the switch. And then every other device connects to the switch. Every other device connects to the switch. So I don't have to depend, this computer right here does not need to depend on this computer right here to be able to get internet connection. If this computer goes down, these other 4 computers are still going to function. The only way this network is going to fail is if this switch in the middle goes down. And usually they're not going to have just one switch. They're going to have a backup switch, like 2 backup switches, that if this one goes down, then the computers, the other backup switch is going to pick up. So think of it like there's another switch here. This guy connected to the switch, this guy connected, this guy connected, this guy connected, and this other guy connected. So this switch goes down here, the other switch here, which is a standby switch, takes over. So this is simple to manage. And if one device goes down, it doesn't affect the rest of the other devices in that network, unless the central switch goes down and there is no backup switch. Okay. Now look at the mesh. In a mesh topology, you see that it is not like a ring where everything is connected. Everything is connected, but there is no connection between this machine and this one. So it's almost like a ring, but it's not a complete ring because there's a space between these two, which means that the connection between this machine and this machine can fail. However, because this machine is also connected to this one, it's still going to be able to stay in the network. The connection between these two can fail, but this machine will still be in the network because it's connected to this guy and this guy. Similarly, this one is connected to this and this. So if the connection fails from here, this machine is still going to have connection because it's connected to this guy who's connected to this guy. The only way the entire network will fail is if, for example, the main machine that brings the connection to this network fails. So for example, if this is the main machine that brings the connection and it fails, that's the way this network is going to fail. Other than that, a mesh topology is a solid topology. You can always keep a mesh. But like a fully connected topology, meshes are also difficult to support because you have a lot of connections, right? You want a simplistic, very simple network topology that is easy to manage, and you can look at the topology and support. When everything is interconnected in an intricate network, it becomes confusing and hard to support. So most environments, you will see a star, others might have a mesh. Bigger organizations can deal with this if they have the capital to hire all the experts to support this. But if I go in any environment and I'm dealing with something like this, I won't be happy. And one thing about networking is that every network topology is highly detailed. All the configurations are detailed. So when a configuration like this is set up, they do a lot of documentation. So if another person is coming in, you can look at the documentation and able to tell how that network is connected, interconnected. So that's why I said, if you start working as an IT professional, the first thing you want to know is what kind of network topology is running in that environment and why. Go ahead and even ask for the documentation and look at it, so you fully understand why the company is functioning the way they are functioning based on their network topology. So that is just a brief explanation of what network topologies are, and these are their diagrams. Okay, so let's go back here. So
I have a question real quick, Gerald.
Yeah.
What's usually the reason why companies go with any particular one? Is it cost benefit effects, or and which one is the most common one that people use, that most companies really use?
Like I said, most companies will listen to their network engineers. So if your network engineer is telling you to do a star topology or a fully connected topology or a ring, they should be able to back that up with an explanation of why they want the company to do a star topology or a ring topology. So I cannot tell you why a particular company will be running a particular topology. When you start working there, it is your place to ask them, like, why are we running a ring instead of a star? What is the reason behind this? And they'll explain it to you. Maybe they are supporting some kind of application that needs some kind of high data transfer that the network needs to be set like that. Who knows? I don't know. but they'll have different reasons why they are setting it like this. But like I said, you want to go for something that is easy to manage, a star, right? Rings are also easy to manage, but think of a situation where the connection cuts here and it cuts here. Then you see that half of the company is down without internet, and then the other half internet. So it's going to be like the network is separated if a ring cuts in the middle. So you have to think about all those things before you go ahead and design a network topology. Network topologies are designed by network engineers. Your part as a Linux admin or an AWS admin, you're not gonna be part of designing a network. No, that's not gonna be part of your job. But you're gonna be part of understanding how the network is designed and why the network is designed the way it is for you to be able to configure your devices. Say you are deploying a Linux server and you are getting your IPs from a particular subnet. You have to understand why the IPs are coming from a particular subnet or why you are doing subnetting against not doing subnetting. If you want to do static IP addresses as against doing dynamic IP addresses. Dynamic IP addresses are IP addresses that change, that you just connect your device and it gets an IP, So if you're doing something like that, you have to understand that environment and why it's set up like that and where that IP address will come from what server.
Okay.
But as far as the design and the implementation of the network design, it is not your job. Even when you go to an interview, if they ask you about, have you ever designed a network, you tell them straight up, you're not a network engineer. You're a Linux engineer, you're a cloud engineer. You don't design networks. But you work with a networking team that do designing. Your job is to understand networking enough for you to be able to do your job as an IT, as a Windows or Linux or cloud administrator. You don't do anything to do with design, no. And if you ever get in an interview, tell them you're not a network administrator. Any other question?
Thanks a lot, Gerard. That answers my question.
Yeah, so when you go into an environment, don't expect to find a particular topology. It could be any topology, like I said, but be familiar with it and ask why they are doing that topology. Ask them why. They'll explain it to you. But something like this, if I hire a network engineer and he comes and designs a ring in my environment, I'll tell him you're not serious. I wouldn't want to go for a ring, because like I said, if the network cuts in the middle, if there's a breakage here, then half of the company will be without internet. Same with a bus topology. If the internet connection breaks in the beginning here, the rest of the company is going to go down. This one is good, but it's too complicated. It's too complicated to support. This one is complicated too, but not as complicated as a fully connected network. So you want to go with a star. That will be my recommendation. Okay, let's continue. So those are the network topologies.
Question, sir.
Yes.
I was made to understand that an IP is a unique address of a computer or a system on a network.
Yes.
But from the explanation given, I'm beginning to develop another conception of what an IP is. That an IP could also mean an address that a server or a host, a server assigns to the computer. I don't try to get
People
it.
is talking. I don't.
Okay.
Two people is talking.
When you're done talking, please mute. There's a lot of background noise coming from where you are, Bismarck.
Okay, all right. I'm done.
Yeah, mute yourself. Nice, thank you. So to answer your question, Bismarck, an IP address is a unique number that is assigned to every computer that wants to communicate on a network, right? That definition is correct. Now, the follow-up question you ask is, okay, where, from what I just explained, you kind of feel like that address is given by another computer, right? Which is true. When you buy a computer and you come into your home, you unbox that computer and you connect to your network. That computer gets an IP address. Do you know where the IP address is coming from? It's coming from somewhere. You don't buy a computer with an IP address. You buy a computer with a MAC address. A MAC address is known as a physical address. Every machine or any device that you buy, it could be a laptop, it could be a phone, no matter the device that you buy, it comes with a MAC address. The MAC address is like a physical address. MAC addresses are embedded in the machine. If you look at the bottom of the machine, you'll be able to see a MAC address somewhere, you know. But an IP address doesn't come with a machine. An IP address is assigned to a machine when a machine connects to your network or to the internet.
Thank you. Continue. Go ahead.
Now, the question now becomes, where does that IP address come from? Who assigns that IP address to the machine? And the answer to that is this guy. Let's go all the way down here. Go all the way to the bottom. And we'll talk about DHCP. Your IP address comes from DHCP. And DHCP stands for Dynamic Host Configuration Protocol. So in every environment, there is a DHCP server. And the work of DHCP is to assign IP addresses to devices. So if I visit Jarvis, for example, and I say, Jarvis, I want to connect to your network. Please give me a username and password to your Wi-Fi. And I connect to your Wi-Fi. Immediately before the connection happens, the DHCP server in Jarvis's environment will assign an IP address to my machine before I can connect to the internet. So at home right now, you all have DHCP servers. You all have DHCP servers. That is why you are able to connect your phone to the internet at home. You have a phone, you have a TV that is connected to the internet. Every device at home that you have that is connected to the internet has an IP address. Without an IP address, that computer cannot connect to the internet and talk to other devices. And the IP address comes from DHCP. Now you can ask me, oh, I don't see any DHCP around me. Where is the DHCP, right? That's the next question I think most of you are going to ask. Where's the DHCP server?
I was about to ask.
Yes.
Is it in the router or like?
The DHCP server is part of the router. It is embedded in the router such that it just assigns your device an IP address as soon as the device is connected to the network. So your ISP or whoever provides the router for you will configure DHCP in that router and make it such that each time you leave your network and you come back in, DHCP sends an IP address. But the thing with DHCP is, so Jonathan, let me ask you this question. So if DHCP sends you an IP address and you're working with that IP address, you leave your network and come to my network, are you still going to have that same IP address? What do you think?
No, I think you're going to have a different IP address. If I leave my network and come to your network, based on whatever DHCP server is configured with your router, that is the IP address that will be given to me. Okay,
thank you. That's correct. Guys, pay attention to everything we're saying right now, because if you miss it, you will miss it for good. You know, networking is very important. You need to get the basics.
Thank you. Now, sir, please, I have something to say.
Go ahead,
what Professor Gerard has explained is something that has confused me like a year now. It looks very simple, but I've been in hell for close to a year right now because of it. And like 3 professors have not been able to resolve it. Please, I've confused that machine, the VirtualBox which I downloaded. I tried to do some stories online, but when I tried to do something like ping, in other words, the system that I have, the VirtualBox I had, was never having network within it. So I had to ping it to a host.
Yes.
In the attempt to do that, I was wanting to force it to be only to the IP address that the DHCP embedded inside the router in this my network here had assigned to the VirtualBox. So I was forcing something that would never work. Anywhere I go, I say, no, I want to ping it but only to that particular IP. It will work like 10, 15 minutes and fail.
And
I will go to all the biggest technicians. It will only be up and down. Then it was like I was completely off the game. Thank you very much.
So, please, one more question. I'm really sorry. Yeah,
go
so
ahead.
In terms of the DHCP, so does it assign the same IP address to whatever device that signs on? For instance, if I have, let's say, about 4 laptops and all of them have been connected to my network, do they get the same IP address or they get different IP addresses?
Okay, good question. So there is something you're actually dragging me into something that Charles will cover, but I'll just give you a hint. So there is something called IP address range or DHCP, let's say DHCP scope. DHCP scope, right? So the DHCP scope is where does DHCP start assigning addresses and where does it end, right? It could start from 1 all the way to 255. So the first device will be .1, the second device will go .2, next device .3, right? Say for example, if your IP address is 10.0.0.5, for example, right? So DHCP can be configured to start giving addresses from .5, right? The next device that connects to your network will get .6, but it's still gonna be 10.0.0.0, then .6. The next device will get .7, next device will get .8. So those are different IP addresses, right? So it will go all the way to, let's say the DHCP scope is 250. I don't think you're gonna have 250 devices in your network. No, right? So even if I bring 10 machines into your network and Bertrand brings 10 and Bama brings 10, there is no way we're gonna hit 250, no way. And remember, there is something too about DHCP. The IP address that DHCP sends to your device is not permanent. It's like you are renting it from DHCP. So DHCP actually leases the IP address to your device. And the lease period could be between 7 and 14 days. Could be between 7 and 40 days. So DHCP leases that IP address. If you keep using the IP address within the 14 days, the IP address is actively being used, which means you are connected to the network, to the internet, and you are doing stuff. DHCP is just going to renew that IP address. It's going to renew that lease, sorry, right? And allow you keep using that IP address. If you leave your network, for example, and you go on vacation and you stay for 1 month and you come back into your network, DHCP assigned you, before you left, you had a .6, like 10.0.0.6. DHCP would have assigned that address to somebody else and then assign you maybe a .10, for example. It makes sense?
Yes, please.
Yes. So DHCP is very important. At home, DHCP is configured to just send out addresses to, that's the only thing DHCP does. It assigns IP addresses to machines. Any machine that is joined to that network, DHCP automatically assigns that machine an IP address. Remember, if computers don't have IP addresses, they cannot communicate. think of an IP address like an SS number. It is unique. No two machines will have the same IP address. It will never happen. If it happens, that is what is known as an IP conflict. It can happen. Let me not say it will never happen. Sometimes at work, there is an IP conflict where you do a configuration, Jonathan, and you configure a machine and you assign a machine a fixed IP address. And I don't check the documentation of what Jonathan did yesterday. I build another machine and I assign the same IP address that you assigned to another machine yesterday. And the two machines are on the network. There's going to be something called an IP conflict, which means two machines are trying to use the same IP. A conflict is going to happen and both machines are not going to communicate. Okay, so that is the thing about DHCP. Let me repeat again. The work of DHCP is to assign IP addresses to host or computer devices that joins the network, right? So it does it dynamically. That's why it is called dynamic host configuration protocol. It does it dynamically. So now, but let me clarify something here. DHCP here is a protocol, and I'll tell you what a protocol is. But when you have DHCP installed on a server, then that server becomes a DHCP server. But DHCP itself is a network protocol. So for example, let me give another example of a protocol. Another protocol that we can use is SMTP. SMTP is a protocol that is used to send emails, right? If I take SMTP, the protocol itself, I configure SMTP on a server to be able to route emails. You send me an email, SMTP takes the email and say, okay, this email is addressed to Jonathan. I'm going to send it to Jonathan. Because I've configured SMTP on that server becomes an SMTP server. But SMTP itself is not a server. A lot of people get confused on this concept. Like, what is a protocol and what is a server? Like sometimes you might go to an interview and they ask you, what is DHCP? Your answer to that question is DHCP is dynamic host configuration protocol. Finish. That is your answer. Now, if they ask you how does DHCP work, or how does a DHCP server work, or how does DHCP function, that is when you explain the concept about DHCP dynamically assigning IP addresses to devices on a network. Am I clear with that, guys? Okay. Okay, so I'm gonna have somebody explain. So Cesar, try to explain what I said about DHCP. Differentiate between DHCP protocol and a DHCP server. I want to make sure you guys understand.
DHCP is dynamic host configuration protocol,
Excellent.
which assign IP addresses to various computer on the particular.
I think its network is kind of fuzzy. Fizz, can you complete it?
Yeah, like he said, DHCP is a dynamic host configuration protocol. It's used to assign IP address to network or to devices that is being connected to that uses the same network.
Mm-hmm. So what then is DHCP server? That's what I want you to differentiate between DHCP and DHCP protocol and DHCP server. I want you to make a distinction based on what I explained.
I think a DHCP server is when a router is configured to have the DHCP protocol.
Exactly, that is what I explained. So, like I said, they might ask you in an interview, what is DHCP? They are not asking you what DHCP does. If you say DHCP assigns IP addresses, you are talking about the DHCP server. So be very careful. Like I explained to you earlier, you are getting an IP address on everything, all the devices on your network because of the DHCP server. And the DHCP server is configured in your router. The DHCP protocol itself does not assign you an IP address, right? What assigns you an IP address is the DHCP server that has been configured to assign IP addresses. So if the DHCP server is not configured, you can have DHCP around that environment, but it's not going to assign any IP address to anybody. So take note of that. And again, like I said, DHCP only leases out IP addresses between 7 and 14 days. After that, if your device is still actively using that IP address, DHCP is going to renew that lease. It's just going to keep renewing the lease. If your device is not using that IP, DHCP is going to take back that IP address and assign to another device that becomes available. So take note of that. So let's go back all the way up here. The question had to drag me all the way to the bottom.
Can you just I just got confused now. I'm sorry.
Yeah.
So DHCP network protocol is what is? Can you like just briefly explain that? I just got confused.
Come again?
So can you please re-explain it just for a brief second, the DHCP network protocol?
Yes.
I just got confused.
DHCP network protocol is dynamic host configuration protocol, right? DHCP server is what actually dynamically assigns IP addresses to devices on a local area network or a network. So DHCP itself is a protocol, and I'll tell you what a protocol is. So let me just go ahead and tell you
DHCP doesn't have an explanation.
A protocol is, go ahead.
I said, so DHCP doesn't have an explanation.
DHCP is a protocol. I'll explain that by explaining to you what a protocol is. So in networking, a protocol is simply put, it's a set of rules that determine how communication happens in a network. Like the word itself, protocol. If I tell you, Faith, you need to follow class protocol, right? It means I'm telling you that there are certain rules in class that you need to follow, right? That is what a network protocol is. It's simply a set of rules that must be followed before communication happens in any network. Communication doesn't just happen anyhow. There are rules in place which are known as protocols that needs to be followed before communication can happen in a network. So DHCP is part of the list of protocols. HTTP is a protocol that you use to surf the internet. Like for example, if I go and I type, someone should give me any give me any website address. Jude, any website address. You're muted.
So let's keep using Facebook since we'll be using Facebook.
Okay, facebook.com, boom. Right? So, well, let me actually open the one for a bank. Let's say Bank of America. And I'll click here. Okay, it's not really giving me what I want. They're overcrowding the web browser. But look at this, guys. Every website has a www. Before the www, there is an HTTP, which is what I'm trying to get at, which is a protocol that you use to surf the internet. Okay, let me open any other website. Let me do ask.com, for example. right? So if I come here, like guys, remember I said anytime you open a website, to make sure you're actually browsing a secure website, make sure there's a lock here. If you don't see a lock here on that website, run away from that website. If it doesn't matter if it's a website that you are familiar with, if you don't see this lock right here, which tells you that this website is protected, it is encrypted, and it is secure, please run away. You're gonna get hacked, or you're gonna have your information stolen. So take note of that. You see, when I click here, what does it say? Connection is secure. If this log wasn't here, you wouldn't see this. And you know that you are browsing a website that is not secure and your connection is not secure. Which means the connection that leaves your house and hitting that website that you're trying to open, the connection is not secure. A hacker can intercept that connection and steal your information. So that is just on the side for you to know. So every website that you visit, make sure you're an IT professional now. It should have this log right here. That's what tells you the website is secure. And the website must have a valid certificate that proves authenticity, that this is a secure website. And you can actually view this certificate. If you come here, it tells you this certificate is intended for the following purposes: proves your identity to a remote computer, ensures the identity of the remote computer, and then it gives you the identity of the remote computer. This is like the IPv6 address. And then it tells you who issued this certificate. CNZ said they are like an official recognized certificate issuer. They issue web certificates to prove that connections to certain websites are secure. You need a web certificate by an authorized certificate authority issuer.
Oh, excuse me. I want to know, why is it valid for only 3 months?
Come again, bro. Your volume is not too clear.
Why is it valid for only 3 months?
Because you need to continue renewing the certificate to prove authenticity of that website. Because the certificate issuing authority, they also need to be making money, right? So like an antivirus, your website certificate will expire. And when your certificate expires, your website is prone for internet attacks, hacks. So you need the certificate to tell whoever is visiting your website that your website is secure and it has a valid certificate to prove that the website is secure. So the certificate could be issued for like 1 year, for like 6 months, you know, and after that it will expire and you need to keep renewing. You can click here, you'll see more information on what the issuer is saying. But hackers are very smart. Hackers can try to duplicate or come up with fake certificates and tell you that it's from the certificate issuing authority, which is not. So you should also be careful. So normally, every time you're connecting to a website, you're connecting through some internet protocol, right? So the protocol that you use to browse web pages, use to browse the internet, is the HTTP protocol. Now, so if I type, let me do this just to show you something. If I type google.com, right, it's gonna take me to Google. You're not gonna see the protocol. But if I cancel this and I start type HTTP, you see the entire thing comes out. So HTTPS is a protocol that you use to communicate in the internet. You must use this protocol. So that's why I said a protocol are a set of rules that determine and govern network communication. So different communications over a network are governed by different protocols. So DHCP is just one protocol among maybe 50 to 100 different protocols. So there are a lot of protocols, and each protocol has what is called a port. Remember, I told you that we're going to talk about ports again, and the port I'm talking here, I'm referring to here, is not the peripheral ports around the computer. So let's get that differentiation. Let's differentiate that very, very quick before people start getting confused. Peripheral ports, display ports, those are physical ports that are around the machine. Those are connectors. You can take your USB and you connect your USB to a USB port on a laptop. A network port is different. Every network protocol, like I said, has a port that connects that protocol to that port. You cannot change it. Like DHCP has its port. DNS is another protocol. It has its own port. HTTP has its port. So we're talking about HTTPS. So you do have, we have HTTP and we have HTTPS. And if you go refer to the document I shared with you 2 days ago with those abbreviations, HTTP stands for Hypertext Transfer Protocol. Then if you add an S in front of HTTP, it is simply saying that this is the secure version of HTTP. And if you have a secure version of HTTP, then you're going to see the lock in front of the website you visit. So if we go to the website that we were visiting before, Google, so Google has this log right here. It already tells me they are using HTTPS. That is the secure protocol they are using. Now you can see right here, HTTPS, because I started typing HTTPS, because I know HTTP and HTTPS are protocols you use to navigate and to connect to a website. They are protocols you use to browse the web. You know, so if I type Amazon.com, same, you're gonna see the same thing. You're gonna see the lock here. As soon as you see that padlock, know they are using secure HTTP or HTTPS. But it's not gonna be part of the web address. But if I click here and I start typing HTTP, then it's gonna show up. You see, it already tells me HTTPS. And guys, HTTPS, like I said, every protocol must have a port. HTTPS uses port 443. And the reason why I'm able to open google.com right now is because this port is open. If port 443 is closed, I'll never be able to access this website. So each time you hear of HTTPS, think of port 443. If you hear of HTTP, which is not the secure version, they use port 80. So we're gonna dive deep into protocols and ports, but I just wanted to explain to you what a protocol is. Like I said, a protocol is a set of rules that govern how communication happens in a network. DHCP is a network protocol, and DHCP has its own port. DNS is a network protocol. HTTP is a network protocol. HTTPS is a network protocol. There are lots and lots of protocols we need to know. But in this class, I won't want you to know every network protocol. I want you to know just 11 of them and their ports. And we're going to come to that later. So let's talk about types of networks. We have 15 more minutes and then we'll take a break. Let's see. Yeah, take a break in 15 minutes. So types of computer networks. Yeah, go ahead.
Yeah, I was saying before you move forward, like, you know, what is the proper order? Like the DHCP protocol, but the difference with the server, like how do you really put them like in order if you're trying to differentiate and the proper like explanation between the two, like the DH protocol and the server, like because you said the DH protocol doesn't assign IP addresses to computers. So how will you put them? Like I need just that proper order explanation.
I just explained that with the question Faith asked. Faith asked, okay, what is DHCP? And I said DHCP is dynamic host dynamic host configuration protocol. So DHCP is a protocol. That is DHCP. And if you understand what a protocol is, then you will not ask, okay, what then is a protocol? That's why I went ahead to explain what a protocol is. And I said a protocol is a set of rules that govern communication in a network. So DHCP is one of those network protocols. But when you configure DHCP on a server, then DHCP server will be able to assign IP addresses to devices on a network. Make sense?
Makes sense.
Okay, thank you, sir. Now, let's talk about types of networks. A lot of you mentioned this in your homework, which is not what I was asking. You know, so I was asking something else, and a lot of you went into network types, you know. But since you already saw what network types are, let's talk about network types right now. So these are the different network types: LAN, WAN, MAN, PAN, SAN. At work, they'll be referring to them by their abbreviations. You'll not hear about local area network. You not hear about WAN. You not hear about wide area network or metropolitan area network. You hear about LAN, things like that. And a LAN or a local area network is a collection of connected devices in one physical location. For example, your home or an office. A LAN can be a small or large range, or large, ranging from a home network with one computer or one device or one user to a large enterprise. So a typical example of a LAN is your home right now. You have a router that is providing internet to your laptop and all the devices in your house. So that is your local area network. That's a typical example of a LAN. At work, you have a router that is providing internet to all the computers within your network at work. Your network is also a LAN. Your work network is also a LAN, sorry. So that is what a local area network is. It's local to you, to a building, or to a school. Does that make sense? Or to an office. That's what a LAN is, a local area network. It's local within you. So you have your router sitting at home right now. That is your home network or your home LAN. It is local to you and your devices. Does that make sense? Okay, so if I ask you guys, what is an example of a LAN? Give me an example. Say my home network, your office. If you're running a business, your office is a LAN. If you're working in some school, that school also got a LAN. Your office network is a LAN. So that's what a local area network is, right? Now, wide area network, it is the opposite of a local area network. So what is a WAN? A WAN extends over a large geographical area. So when you think about LAN, the first thing that, when you think about a WAN, for example, wide area network, the first thing that should come to mind is geographical area. It covers a wide space, wide geographical area, right? Or think about a collection of local area networks put together that expand over a large geographical area. That's gonna make a WAN. So a WAN extends over a large geographical area and connects individual users or multiple LANs. So if my local area network, for example, Jude, is connected to your local area network and connected to Emeka's local area network, which is connected to Bismarck's local area network, which is connected to Bertrand's local area network, that all constitute a LAN because it's getting wider and wider over a geographical area, a huge geographical area. So that is what a WAN is. And a typical example of a wide area network is the internet. So the internet is an example of a wide area network. Am I clear? The World Wide Web, the internet, is an example of a wide area network because your LAN is connected to other multiple LANs that span over a large geographical area, which is what the internet is all about, right? Any question on WAN?
For example, office networks which are spread over an area, for example, offices which connect with each other in different cities, can they also be considered one?
So yes, if you take one office and connect to, that is like one local area network connecting to another local area network over a large area, you are constituting a WAN. Yes, but if it depends on the geographical area that it covers, right? It depends. If I'm connecting my building to a building that is 2 blocks down the street, you know, I'm not really going to consider that a WAN. I'm going to consider it as one LAN connecting to another LAN. So it's like if I have a network cable that is connecting my building to your building, that's not going to be a wide area network. That's still going to be one LAN connecting to another LAN. But if my home router is connecting my local area network to your own home router, so my LAN is connecting to your LAN over the internet, it becomes a WAN. Yeah. Then we also have a MAN, which is a metropolitan area network, and a MAN integrates multiple LANs within a metropolitan city. So you can think of a MAN like a smaller version of a WAN that only embodies a city or a town, or an extension of a LAN that only embodies an entire city, if you want to look at it that way. So that's what a MAN is. And a best example, think of a cable television network that spans over an entire city. That's an example of a metropolitan area network. It covers a metropolitan area or a city or something. And then we also have PAN, which is a personal area network. And you deploy a PAN mostly in your home. And most of you have deployed personal area networks. And a simple example is putting your Bluetooth on, right, to send a file to another phone, your phone to my phone, exchanging files. We are starting a personal area network between us. Or you are putting the Bluetooth on in your car because you want to play some music, and then you put it on your phone, so your phone connects to the Bluetooth in your car to play music. That becomes a personal area network. If you move away from it, you lose the connection. So personal area networks are short distance, like the range is very, very short. You need to stay close to the device you're connected to. So that's what a PAN is. And then a SAN is a storage area network. Think of SANs as storage, that I have storage devices in my house, for example, tons and tons of storage. I'm not talking about one physical hard drive. Think about the entire room full of storage devices from floor to the roof. And Jarvis, you're in Sweden. I want to allocate storage to you from where I am over the network, right? That is what becomes a SAN, like allocating storage to a device over a network. It's known as SAN. So we have storage specialists. We have people that are trained in IT just to handle storage and configure SANs. So Jarvis can sit in Europe and tell me, hey, I need 500 gigabytes of storage over the network, and I configure it in my house and provision the storage to you over the network. So that's what SANs are. So you have SAN specialists who are otherwise known as storage specialists. They are basically in charge of configuring and managing SANs.
Quick question, Gerard. Is that similar to what AWS and Dropbox and all these cloud storages do when we buy space on their network?
Yes, it is. It is similar, but the thing with SAN is that SANs are more complicated because they use a lot of network protocols within SAN. You have a lot of storage protocols that come in, right? As opposed to Dropbox, where you're just provisioning in the cloud and you just drop, you can just sign up and you you drop your files or whatever you want to save into Dropbox. But SANs are actually used at work. So you can be at work and your company needs storage and your server room is 100 miles away. You will need to provision that storage over the network to assign to a computer at work. And that computer will be a server. I'm not talking about your laptop. You will not configure a SAN to add storage to your laptop. You configure it to add storage to a virtual machine or a virtual server. So SANs, that's why I said, as SAN, you need to be a storage specialist. People are trained, there are IT professionals that are trained to handle only storage. I work with storage engineers. That's all they do, the provision storage. You will think it is easy. I don't want to do anything storage. I have been running away from storage ever since I started my IT career. Storage is complicated. You use a lot of intricate networks and protocols that some of you might like it when you start your IT career. Me, I'm not a storage guy. Even when I interview, they ask me about storage. I just tell them, I have a storage team that provisions storage and allocates to me. And when they allocate the storage to me, I can use the storage and format it with a file system and do what I want to do with it. But just understand that a storage area network, otherwise known as a SAN, is used to provision storage to servers. And when I talk about servers here, I'm mostly talking about virtual servers over the network. That's what a SAN is. And that is that. So let's talk about 1 minute to break time. Let's talk about network based on functionality, networks based on functionality. And then we'll talk about client server network and peer-to-peer network. Guys, learn these terminologies. You need to understand and be able to understand them when you hear about them. So don't just read them and pass. Understand these terminologies. You hear about client server network. You hear about peer-to-peer network. What is a client server network? It's a network connection that has a server involved. So a client makes a request to the server and the server delivers. That is a client server network. So for example, we've been going to the web browser and typing facebook.com and it's connecting us to facebook.com. So we are the client and we are using a client application, which is our web browser. So if you use Firefox, for example, or Google Chrome, whatever web browser you use to connect to Amazon.com, Facebook.com, or any other website out there, like I said, you are actually connecting to their server. So you are the client, and the client application you are using to start that connection is your web browser. Your web browser could be Google Chrome, it could be Safari, it could be Microsoft Edge, it could be Internet Explorer. That is your client. So a client server network means it's a network where clients make a request to the server using a client application, and then the server delivers the request. So if I type facebook.com, I'm using my web browser to make a client request to the Facebook server to serve me a Facebook page, and then the server is going to serve it to me. That is a client server network. A peer-to-peer network is two computers communicating without any server involved. Say I have data on server on laptop A. Laptop A is connected to laptop B. I want to transfer data from A to B, and laptop A sends the data to me without going through a server. That is known as a peer-to-peer. Like A is tied to B, no server in between. That is it. Any question? Otherwise, we take a break.
No, that is easy to understand.
Okay.
It's like pairing two devices.
All right.
Yeah.
So take note of the terminologies, peer-to-peer. And it is always spelled like this. Client server is always spelled like this. There is a dash between client and server. Peer-to-peer, there is a dash between peer-to-peer, like that. It's always going to be like that. Don't spell like single words. It's always going to be like that.
Yeah, Mr. Jared. So when you said that you use the Firefox to access the website of Facebook,
please use the right terminology. Don't use Firefox. I use a certain terminology that I want you to use.
okay, we use a web browser.
Thank you.
Right?
You're an IT professional right now.
And I should use a web browser. So you said the web browser functions as a client request.
It functions as a client. So you are using, it functions as a client application. You are the client, okay. Right? You are the client. You want to use a client application to contact the Facebook server, and you are using a web browser. So your web browser becomes the client application.
Okay, got it.
Yeah.
Got it, thank you.
Any other question? Okay, so let's come back in 10. And please come back on time. Okay, so for those who came late, let me rewind and explain what I was explaining before you came. So we're talking about protocols, like I said. And I told you every protocol, network protocol, you can also call it a service name, but though they are usually known as network protocols. And I said a protocol is simply a set of rules that govern how communication happens in a network. Every protocol has a port number. And think of a port like this. Okay. Let's say, Jude, you send me your address, right? You live somewhere in Worcester and you send me your address. Within your apartment, you have 4 rooms within your apartment. I don't know what room Jude is in. The letter has been addressed to me to take to Jude. And Jude lives in 452 Main Street, Worcester, for example. And I go to 452 Main Street and I go into Jude's house. He's in one of those rooms. I need a port number. Think of that port number as the room in that apartment where Jude is. And if I don't state that room, if I don't state that port, I'll not be able to access that room. I'll get to the destination, I'll get to that apartment, but I won't be able to access the room to actually meet Jude face to face to hand him the letter. And that is what a port is. So that is why every protocol has a designated port. And I said a port is simply an opening that allows that communication to go in and out. So every protocol has a port that is tied to it, and their ports do not change. Secure shell port will never be port 20, never. Likewise, FTP port will never be 22. So once you think of 22, think about secure shell, popularly known as SSH. So these are the protocols and their port numbers. And in networking, like I said, there are two transporters in networking. So if I want to send a message to Jarvis, or I want to write a letter to Jarvis, I write the letter, I know your address, Jarvis, and I address the letter to you. What do I need to do to get a letter to you? I need to take it to the post office, right? Yes. I hand the letter to the post office. So think of your address on that letter as your computer's IP address. Your computer's IP address, not mine. Because I want to send the letter to you, I want to send a message to you. So I need to know the IP address of your machine. So I address the letter. That is your computer's IP address. I give it to the mailman, the post office. The post office is going to transport that mail either by car, and then you're in Europe, they're going to put it in an airplane, and then they fly it to Sweden. It gets to another car, and they deliver it to your home, right? So think of TCP and UDP as the transporters. That's all they do in networking. Each time you send in information, that information will be transported by either TCP or either UDP using one of these protocols. Does that make sense? Do I need to explain again? Or that is understood?
Thanks a lot, Gerard.
Okay. Sometimes there are protocols that can use both transporters. Like for example, SSH can use TCP to transport, to communicate as its transporter, and it can also use UDP as its transporter. And guys, check the abbreviation text I sent to you last week. TCP stands for Transmission Control Protocol. UDP stands for User Datagram Protocol. You should know them. And FTP is one protocol, and this is what FTP does. It's usually used in a workplace to transfer files. It carries data that will be delivered properly. So at work, you usually find an FTP server, which is like a file server. You want to transfer huge sums of files or amount of files. You do it using FTP and using an FTP server. And when I say FTP server, what do I mean? I simply mean a server that FTP has been installed and configured on. Does that make sense? It's the same with DHCP. DHCP server simply means DHCP has been installed and configured on a server to be sending out IP addresses dynamically. So all these protocols, like I said, every protocol will have its own port, and you have to know a protocol and its port. This is the most common interview question in networking. They'll ask you, what is secure shell? What is its port? What is HTTP? What is it used for? What is its port? Very common question. And if you don't get them right, you're doomed. Telnet uses port 23. You are able to send emails because of this guy, SMTP. This is a protocol that is used to send email. Otherwise, it is known as an email server in some environments. So if you hear about email server, they are talking about SMTP, Simple Mail Transfer Protocol. So it tells you in the name that it is used to transfer emails. So all of these protocols will do different things. They have different functionalities based on the rules that have been set. And like I said, a protocol transporter will either be TCP or UDP. And this is what SMTP does. It is a communication protocol which is used to transmit email messages over the internet to the destination server. That is what the protocol does. And the list goes down. domain name system. I'll explain this one later. This one is very, very important. DNS uses port 53 and it uses both TCP and UDP. You should know that. And then trivial FTP uses port 69. Let's keep going down. We're gonna come across DHCP. You see, DHCP is one protocol here. And these are the DHCP ports. DHCP uses 2 ports, 67 and 68. And DHCP is UDP. And then you also have POP3. POP3 stands for Post Office Protocol 3, version 3. They don't use POP3 anymore because what POP3 used to do is that, okay, you send an email, the email goes into the Post Office Protocol server. And after you read that email, the server deletes the email. So you don't want your emails deleted, right? You want your emails to come in your email box and stay in your email box, right? But POP3 usually don't keep the emails. As soon as you read the email, you come back later, the email is gone. If you don't take a backup of that email, you're not going to find that email. So because of the shortcomings of Post Office Protocol 3, they had to develop SMTP, this one right here, Simple Mail Transfer Protocol. And this is what you currently use right now with whatever email service that you're using. Gmail, whatever email you're using is using SMTP. And that is why you can log into your email box and you read your email, come back later, the email is still there. Because SMTP is not going to delete your email, but POP3 is going to delete it. So
that means that Google servers are majority of them are configured for the emails.
Can you be a little bit loud, please?
So does that mean that Google, like Gmail, Yahoo Mail, so that means that all their servers that host or keep our emails are configured or with SSTP?
Yes, and this is something you should understand about email. The email you see is not actually in your email box. It's actually on Gmail server. For example, we all have Gmail. Each time you get an email, it's not actually in your email box. It is on Gmail server. So the reason you are able to see that email because you are using an email client to download that email into your email box so that you can read it. So it takes us back to our client server model we spoke about before break, right? Where you have a server that the client makes a request and pulls information from the server. It is the same way emails function. Emails function on a client server model. So yeah, each time if I send you an email right now, Emeka, the email is going to go to the Google server, right? And then from the Google server, it's going to go down to your own email box. So your email, Gmail itself is a client that you use to pull that email from the Gmail server. That's how emails work. So that's why I kept telling you servers control the world. Your understanding of servers should be top notch. The world is controlled by servers. Everything must go through a server. So
that's crazy and scary at the same time.
So this protocol right here, NTP, it controls time, and the port is 123. This is the easiest port number to remember, 123. So Jude, I'm gonna ask you on Wednesday, NTP port number. Don't tell me port 10. It's 123. It's the easiest protocol port number to know. There's also NetBIOS, which is used to configure like phone lines and all that. You don't need to know all of these protocols. In this class, in total, there are like 65,539 protocols. I repeat, 69,539 protocols. But in this class, I require you to know just 12. And the 12 you should know, I'll send them to you after class. And you should know them, their protocols, and their means of transmission, either TCP or UDP. So next week, Saturday, if I come to class and I say, what is NTP? I expect someone to tell me network time protocol, what's its port number, port 123, what's its means of transmission, UDP, and what's the protocol used for? It used to synchronize time. You switch off your phone, you leave it off for like 5 hours, you come back, switch on the phone, your time doesn't get distorted. Your time, if you switch it off at 12 and it's 5 p.m., you still get 5 p.m. on your phone. Why? Because of NTP protocol. The protocol synchronizes time across devices. So I'll send you the protocols that you need to know on this list. There are a lot of them. You see HTTPS that I was telling you about, it has its own port. There's also IMAP. IMAP is also used to retrieve emails from mail servers. There is app address resolution protocol. This is one of the protocols that you should also know. So I'm going to send the list of protocols to you that you need to know, and their port numbers. Their port numbers are very important. You need to memorize them. There is no other way when it comes to the port numbers. You need to memorize them.
I think some of those protocols were highlighted on Professor Mensa's notes.
Exactly. That's someone who's been studying.
Yes, but it never had the port numbers. So I think that was the only thing that was missing. So, but their protocols were highlighted. So
okay. Yeah, so that's why I tell you guys, watch the videos, and then when you come to class, I expatiate. I take it to another level.
It actually has the port numbers. I think it always starts off with the port number and the protocol.
Okay. So these are the protocols. Like I said, I will send you the ones that you need to know. You know. So we're going to talk about this today, NAT. NAT stands for Network Address Translation. It's very important. I'll come to it in a second. So that is it for protocols and ports. Now, let's talk about motherboard peripheral ports. Let's go back to peripheral ports. So what is the difference between a peripheral port and a network port? Jonathan. You are muted.
So peripheral ports are ports on a physical computer that we see. So such as ports that connect to like ADMIs and VGI. But network ports are ports that actually communication is done through like network port. Let's say, for instance, if I want to use the internet, www dots. Okay, let's say if I want to go to my bank, I know it goes over port 443, which is the HTTPS.
Okay. Good attempt. Who else should try? Cesar, you want to give it a shot? Who else want to try?
Are these not different ports on the computer, like the USB, HDMI? The question was peripheral ports, correct?
Yeah. How do you differentiate a peripheral port with a network port?
Yeah, I'll let somebody else try.
Okay. I just explained. Okay. Jarvis.
I would say that the network ports like they deal mostly. I would say they are software because you can't really see them, but the peripheral port is much more physical, which you can actually
Okay.
plug in using. Yeah.
So I explained, I gave an example of using a network port by taking a letter to deliver it to Jude in Worcester. And I said, if I take the letter to his address, I know he's in that building. And I get into that building and I get into his apartment, and there are 4 different doors, 4 different rooms within. Let's say I'm standing in his living room. He's in another room within that apartment. I see 4 different doors. For me to be able to access the room that he is in, I will need to know the door number. So think of a port like that. If I want to go deliver that mail to him, to know that, okay, Jude is actually in this room, I need to go through this port. I need to go through that door. Is it door 1 or door 2 or door 3? I said he has 4 doors in his house. So if I don't know the door number, I'll not be able to know exactly where he is, even though I'm in his apartment. So that's what the network ports are. They are used to specify that even though you are using this protocol, for this communication to happen or for this data to be delivered, you need to go through this port. If that communication doesn't go through this port, then that data is not going to be guaranteed any delivery. It's not going to be delivered. So that is what the ports are used for. They are communication ports. They are used for communication. And every protocol has a designated port. Okay. So peripheral ports are the physical ports around the machine. An example of a peripheral port, 1, USB. What do I need you to know about USB? A USB transmits up to 5 volts of electricity, electrical charge. I know some of you charge your phones on your laptop, right? You charge other devices from your laptop. But you can get this question in an interview. How many volts does a USB port actually produce? It produces 5 volts. So have that in mind. And now let's keep going. There are different types of USB ports on the machine. Not all USB ports are the same. You have USB version 1, you have version 2, and version 3. So they go by V1, V2, V3. And those ports transmit data at different speeds. USB V1 transmit, the data transfer speed is 12 megabytes per second. Version 2 is 480 megabytes per second. And it's usually black. Most laptops will have a black port. So look around your device and tell me the color of the USB. You can differentiate between the versions by their colors. So take a peep at your USB port and tell me if it's black or blue. If it is blue, then you have a V3, which is the fastest USB port. And it transmits 5 gigabytes of data per second. So I can ask you a question, right? And I say, Jude, I'm transferring data from my machine to your machine. I put it in my machine. I was able to just drag the file and put it in the USB. And I took it to transfer the same data to your machine. And it's taken a while. What could the problem be? The first thing you have to think about is the USB port. What type of USB connector do you have? Is it a version 1 or version 2 or version 3? Because they transfer data at different speeds. So if it's a version 1 USB port you have, the data transfer is going to be slow. So I will take my USB thumb drive and I put in your machine, and I'm transferring data from my device to your machine, or copying data from your device into the USB drive. It's going to be slow. And we are wondering, like, what is wrong? Is it the machine? Is it the hard drive? No, it's not the hard drive. It's the USB port. So that's how you should be thinking. You should understand these things. And like I said, the USB V3s, they are the fastest. They are usually blue. So check around your machine. If you see any blue connector, know you have the fastest USB port. If you see it, if it's black, it's probably the version 2, which transmits data at 480 megabytes per second, which is still good. If you have the version 1, which is transmitting at 12 megabytes per second, throw away that computer. Okay, let's move on. Let's talk about network interface cards, otherwise known as a network controller. In IT environments, you hear about them as NICs. You never hear about network interface card, or network interface controller, or network adapter. You always hear them being referred to as NIC. Your NIC, your NIC, your NIC. Your NIC is very, 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 very important. Your NIC is very, very important for internet connection. If you are a network controller, as it's being called, it's also called a network adapter. It's also called an Ethernet card. Guys, take note of this word, Ethernet. I didn't say internet. I want you to pay good attention here, please. Ethernet versus internet. Those are two different words. They mean two different things, and you should pay attention to them. Ethernet. Ethernet. So when you're referring to Ethernet, what are you actually talking about? You're talking about a particular type of technology. So you're talking about, let's use a local area network, for example. If I come into your local area network, I'm gonna probably see a router. I'm gonna probably see a network cable that connects from your router to some device and also connects to some other device. All those cables, the routers, they form what is known as Ethernet technology or Ethernet connection. It is different from the internet. The internet is the World Wide Web. So if I have a switch, a router, fast network cables, fast USB port, all of that comprise an Ethernet connection. Ethernet. Internet is talking about connecting to the World Wide Web. That is a possible interview question. A lot of people confuse Ethernet with internet. So please read more about this and differentiate the two. I'll put it in the homework. Please, you need to understand Ethernet versus internet. So your network adapter is part of your Ethernet
Come
setup.
again with the Ethernet explanation, please.
You want me to explain again?
Yeah, the Ethernet, not internet, the
Okay.
Ethernet, yeah.
So Ethernet simply describes a technology. What kind of technology is being used within a local area network or a wide area network? And when I say what type of technology, I'm talking about how the devices are physically connected, the connectors. Are they using Cat5 cables? Are they using Cat6 cables? Do the laptops have very fast ports? So all of those, are they using wired or wireless connection? Are they using fiber optic connection or they are using a normal connection? Do they have fiber cables or they have normal cables? All of that, the different connectors that determine the speed of that network comprise of what is known as Ethernet. It is different from internet.
Prof, I just have one question. You just asked not so long about network and peripheral ports. So can we also use this Ethernet and internet to differentiate network and peripheral ports?
Can you use internet and Ethernet?
Yes.
So Ethernet comprises a lot. It doesn't comprise of one thing. So Ethernet, like I said, you are thinking about what kind of card cable are you using to transmit data within that network? Are you using a slow card cable? You are using a fast card cable, right? What kind of network adapter are you using? Is it a built-in network adapter in your machine or is an adapter that is external? What is the mode of data transmission? Are you using fiber connection? Do you have fiber cables? All of this will determine how fast that network is going to be. So you have different speeds of data transfer based on the physical connectors that you use that all fall under Ethernet. So you can use an Ethernet setup that is cheaper, but your internet or setup in that environment is going to be slow because of the type of Ethernet topology or Ethernet connection that you've set up. So if I go back to this document, and I want you to pay attention to this, look at this, Ethernet technology. Okay, it says if you are using 5T, 10 base T, this is going to be the data transfer speed of your network. So 10 base T cables could be slower CAT cables, could be slower network adapters. So if you want to go to like 1,000 base T, this is how fast your network is going to be in terms of data transmission. So Ethernet has all these different technologies based on the physical devices. Like I said, the physical device will transmit data at a different speed. Let me give you an example. I have a CAT cable right here. This is a CAT. This is a CAT cable. Most of you've seen this cable. They come in different colors, right? It's different from a phone cable. Please don't make a mistake. This is a CAT cable. You use a CAT cable to connect computers to, so this end of the CAT cable, it actually connects into your NIC, your network interface card. So if you look at the side of either the left side or the right side, you're gonna see a connector that this can feed into. So just look around your machine. You're gonna see that. Everyone should locate their Ethernet port. It's known as an Ethernet port. Locate it on your machine. If you look at it, a phone jack can feed into it. It looks like the connector looks like it can actually feed a phone jack. So let me show you a picture of what it looks like. Let me do RJ45 port. So so they look like this. There's a port on the side of your machine that looks like this, that you can actually stick one of these into and bring connection, network connectivity into your machine. So has everyone been able to identify theirs? And on the wall, you're gonna see them like this on the wall. You can actually connect this to on it, and then you connect it to your laptop, and you're still gonna get internet connection. If you look behind your router, you're gonna see a port like this, like this. I don't know where your router is at your home, but you're gonna see something like this. You can connect one of these Ethernet cables on your router and connect the other end to the Ethernet port on your machine, and it provides internet over a wired connection. So I'm using an Ethernet cable to connect my router to my laptop through the Ethernet port to get internet connection. Am I making sense? Faith, you don't look convinced. That's why I like when people have their cameras on. So I'm teaching them, looking at people's facial expressions. So that's one of the reasons why we tell people in class to turn on their cameras, not because we want to see you, but as a tutor, it makes me understand. I can look at your facial expression and I'm able to tell if you're understanding what I'm saying or not. So it's not like I just want to see people, I'm forcing people to put their cameras on, you know. So I need to see your facial expression and know if the material is going in or is not going in. So Phil, what is your problem? Explain, tell me what the problem is.
I can't really see the port on my system. Okay. But like you said you connect the cable to the system and then you can connect it to the router. But okay. I'm just trying to locate it. But this particular one you just showed to Ross, I can't see it.
So on your system, it's not gonna be exposed like this. It might have a little covering that will cover the port a little bit. So you have to pull something from the corner to be able to see the complete port. It's not going to be exposed like this. So it might have a covering that will cover up to this level, and then you just see like a little hole, a little entrance into the port. However, some computers don't have Ethernet ports, which means the only way that computer can connect to the internet is only through Wi-Fi. And as an IT folk, that's what you're going to learn in this class. You don't want to go and buy a computer that you can only connect to the internet through Wi-Fi. What if your network card damages or your Wi-Fi get disrupted? Because right now, if my Wi-Fi fails, what do? I just get my Ethernet cable, I plug it to my machine, I plug it to the router, and my internet connection continues without any interruption. If my machine didn't have an Ethernet port and my Ethernet adapter is bad, no internet for you, sorry. So that's one thing you need to put on your list while you are going out there to shop for a machine. After thinking about CPU, RAM, storage, operating system type, make sure the machine also has an Ethernet port. Another name for an Ethernet port is RJ45 port. Some books or some IT folks will refer to it as RJ45 jack. So this jack right here connects to your NIC, your network interface card. Does that make sense? So this jack is actually on your laptop. It's the opening on your laptop. That's the port. And the port connects directly on your NIC or your network interface card, which is part of your motherboard. So let me show you what the NIC looks like. Okay, so this is how it is. So you connect this cable right here. This is the port, the Ethernet port. You connect it right here, and then this is actually the network interface card. This is the NIC. Sometimes they might refer to it as Ethernet NIC. So this is the NIC right here. It controls your machine connecting to the internet. If your NIC is bad, or if your NIC is not enabled, you will never connect to the internet. And you will think, oh, maybe I'm putting the wrong Wi-Fi password, or maybe the internet is not working. So if your machine is not connecting to the internet, the first thing you want to check is your NIC. Is my NIC enabled or disabled? Because sometimes you might reboot your machine and it disables your NIC. You have to go into your machine and enable it. So always make sure your NIC is enabled. When your NIC is enabled, then it's going to accept internet connection. If your NIC is not enabled, forget it. If your NIC is bad, you need to replace the NIC. And how do you replace the NIC? Jude, a customer comes to you at work. I think my NIC is bad. I don't have internet connection. What are you going to do? Walk us through the process. Jude, are you there?
Sorry, come again.
The question is for you. One of your co-workers from accounting walks into the IT department and say, Mr. Jude, I haven't been receiving internet connection all day. I don't know if it's my network interface card. I don't know if it's my NIC. Can you check it out for me? What are you going to do, Mr. Jude?
Oh, sorry. Like okay, his internet is not working. That's right.
Yes, and then you look right. Okay, do you see my machine? Do you see the Wi-Fi signal right here, where my mouse is? You see my mouse, right? Do you see me moving my mouse?
No.
Okay. So if you look at the bottom right-hand corner of my machine, you're gonna see like the speaker. I just clicked on that. Next to the speaker, you're gonna see like the Wi-Fi signal right there. Do you see it? On my taskbar, bottom right of my screen.
Yeah, for some reason, I don't know why I can't see it. I'm not saying it. I don't know if somebody else. I'm not saying that. I don't know
Okay,
if
do you
somebody.
see the Wi-Fi connection on your machine? The part on your taskbar that indicates that your machine has a Wi-Fi connection.
Yes, I do, on the right-hand corner.
Okay, now, so when that machine comes in, that's the first thing you're gonna be looking at, if it's receiving that connection. If the connection is not there, okay, you start feeling that, okay, maybe the network interface card is not enabled or it is bad, right? How do you proceed from there? After checking to see that, okay, Wi-Fi connection is not reaching this machine, what else are you gonna do?
I'm gonna check the ports of the machine. I'm gonna check the port of the machine to see if I can actually connect the cable.
Which port are you checking?
I'm gonna check normally the peripheral port of the machine.
Which one? There are lots of ports around the machine. There is USB port, there's Thunderbolt port, there's HDMI port, there's speaker port. So there's a port for the mouse. So which port are you checking?
The NIC.
The Ethernet port or the network port, right?
Yeah.
Yes. Yeah. I wanted you to use that terminology. So remember, we're IT folks now, and we are training to become IT folks. So our terminology needs to be changing. Our language needs to be changing. Don't just say port. Say Ethernet port, or you check your network port. You need to be specific. So go ahead.
Yeah, so I'm gonna check the internet port.
Ethernet, not internet, please. Ethernet.
Yeah. Ethernet, not Ethernet.
Yeah,
yes,
Ethernet.
Check the Ethernet port.
Yeah.
Yeah, to see if I can actually connect the cable to the device in order to get signal.
Okay, so if you connect, I'm gonna ask a follow-up question. So if you connect, so you have this cable, this is your Cat5 cable. You plug the other end of the cable to a router, and you plug the other end to the Ethernet port on the laptop, right? And if you get a signal, of course, you know the port is working, right? It's not a port problem, right? If you don't get a signal, what do you do? What does that tell you if you don't get a signal?
If I don't get a signal, it means it's not the right port.
It's not the right port. There's only one Ethernet port on your laptop. One. There cannot be two Ethernet ports. It's just one.
If I don't get a signal, it means the port numbers are not the same.
No. You have one. So this is what you're trying to check. You're trying to check if the port is working or is not working. You're trying to check if here's a port right here. This is an example of a port. So you plug the Ethernet cable into this port, Ethernet cable, and you don't get Wi-Fi signal to show you that your machine is actually connected to the internet. So the reason why you are plugging this cable into this port is to establish whether this port is working or not, right?
Yeah.
Whether the Ethernet card is working or not. That's why you're trying to troubleshoot. So you plug the cable in here and you don't get the signal. What does that tell you?
It's not working.
That the NIC might be bad, and you wouldn't know until you perform a diagnostics test on the machine to find out what's wrong.
Okay, good answer, Fit. Excellent answer. But before you go ahead and start performing a hardware test, so I have this cable. I plug it to the router and I plug it to my Ethernet port. I don't get a signal coming from that port. Immediately, am I gonna start thinking that it is the port that is bad or the Ethernet card that is bad? Are you gonna think it's the port or the Ethernet card that is bad? Are you gonna think that way or not? Are you gonna draw that conclusion that, okay, it's the port?
Well, you should plug into other systems to make sure that the other systems will connect to the internet. So once this other system connects to the internet, then you know the Cat5 cable is good. And if the Cat5 cable is good, then you try again connected to the system that is supposedly damaged. Now, if it's not connecting to the internet, then that's where you say, okay, maybe the NIC is corrupted.
Good attempt. Jarvis, say something. What do you think?
I'm thinking that it can be both ways, and
go ahead.
Yeah, I'm thinking that it can be both ways. It could either be from the router or from the computer, and if it's from the, of course, I'll check the router if it's properly connected, and if it's also
properly connected to what? Why would you think is the router? The router is being connected and is giving connection to all other devices. Why would you think is the router?
Okay.
It cannot be the router. Okay, let me go ahead and answer the question. So that laptop gets delivered to you and you check the laptop, there's no Wi-Fi signal showing that, let's say the laptop was connected to the internet through Wi-Fi. There's no Wi-Fi signal. And you are not sure if it's the Ethernet port and the network interface card that is bad. That's your guess. The first thing you want to do is check if the network card is enabled or not. I just told you that like 5 minutes ago. If the network card is disabled, then all the troubleshooting you're doing is a waste of time. Go check if the card is enabled or disabled. And if you don't know how to check that, in IT, Google is your best friend. No one knows everything. Just go to Google, how to enable network interface card. I'll show you how to enable it, right? I'll show you how to enable it. But I'm just giving you tips right here. How to enable NIC. You just follow it's like 5 steps. You just click on it and you click enable. Now you see, okay, the NIC is enabled. If that takes care of the problem, then you know, oh, the NIC was not enabled. But if you enable the NIC and the problem still persists, that is when you go fetch a cable like this. Connect one end of the cable to the router, connect the other end to the NIC, to the network interface card, and watch what happens. If you get an internet connection, then it tells you, oh, the machine had a problem connecting to the network using Wi-Fi. So Wi-Fi is not working, but wired connection is working. Because remember, there are 2 ways your machine can connect to the internet. You can connect it with the wire. And the wire is actually faster than Wi-Fi. That's one thing you should know. The wire is more secure than Wi-Fi. It is hard to hack wired networks. than wireless. Wireless, I can interrupt a wireless traffic. I can interrupt any wireless traffic that is not secure and I hack into your network. So if I do this connection and it works, then it tells me the wireless port is not working or it's not enabled. That is one possibility. So I fixed it by connecting it wirelessly, using wired connection. Then I'll just tell the user, take this cable, go to your office, plug it to in every office at work will have the opening on the wall, the Ethernet open, the Ethernet jack on the wall. So you connect it to that jack and then you take it straight to your laptop and it's going to solve that problem. If you connect it to the router, to the machine, your NIC is enabled and you don't get a connection. You get no internet connection. That tells you there are two possibilities there. It might be that the NIC is bad, or it might be that the cable you are using is bad. You have to think about that. It might be this cable. So what am I gonna do? I'm gonna go grab a different Ethernet cable or a CAT cable. In your office, you have a lot of them lying around you, new ones. So I'm gonna get a brand new Ethernet cable. I connect to the router and I connect it to the port again. If I don't get a signal after using that new cable, then I know for sure it's the port. It's the port. At that point, I can go run my hardware diagnostics. Does that make sense? I can go run my hardware diagnostics. If you are using Lenovo like me, I'll use my Lenovo Vantage that I showed you yesterday. If you are using Dell has its own. So find out what diagnostic is being used on your machine and you run the diagnostic test and it will tell you for sure what is wrong. And at that point, you'll be able to determine that is the NIC. The NIC is faulty. And after knowing that the NIC is faulty, what do? You get your serial number, right? And you know how to get your serial number. WMIC BIOS get serial number. You call your vendor or manufacturer, you explain the problem to them. They might walk you through this procedure again just to be sure. And if it is certain, then they will tell you, okay, we are sending you a box to ship the laptop to us. And if it's under warranty, if the warranty is still existing, they're gonna ship the box, you put the laptop in the box, ship to them, and they're gonna replace the faulty NIC. Any question? I know the hard part of IT is the application, but you guys will get better. Don't worry about it. With time, it's still early for you. I don't expect you to answer all the questions I'm asking, but just know this is how IT is. It's testing the knowledge that you've learned. We can define routers, switches, all of these things. Those are just definitions. But when it comes to applying, if we cannot apply and the application actually makes sense to someone that you're explaining it to, then you're not an IT person. And at interviews, that's how you're going to be tested.
I have a question, Joe.
Yes, sir.
So, if you got the laptop and you get the Cat5 cable and you plug it in immediately, let's say you know the Cat5 cable is good, and you plug it in immediately to the jack in the wall or to your router, and there's no internet, so that automatically tells you that the NIC is bad.
There's no internet.
Yes, if you plugged it into the jack, what you plug the
so
Ethernet
remember,
cable.
I have enabled the NIC, so the NIC is supposed to be enabled. If you plug it into your machine without enabling the NIC, nothing is going to happen, right? Nothing is going to change. The NIC is down, the NIC is down. So even if you plug it to your router and plug it to the port, whereas the NIC is not enabled, nothing is going to change. The problem is still going to be there. So before doing that connection, make sure you've enabled the NIC, or you can do the connection, then go enable the NIC. And then it's going to tell you if a connection happens, then you know for sure that, okay, your machine can connect with a wired connection, but it cannot connect wirelessly. So the problem is your wireless connection. So take this wired cable and go connect your machine. Or you might give the person another machine if you like, and then you go troubleshoot what is wrong with the wireless connection. Simple as that. So let's go back here. So please go read more about Ethernet and Internet. So I put it here in 2 stars. Like, I didn't want to use brackets. I put it in 2 stars. So you actually pay attention to it. So Ethernet is technology that is commonly used in wired local area networks. And I said card cable, routers, switches, all of them, they constitute Ethernet. And based on the speed of data transfer you're going to get in your network, it's going to come down to what kind of Ethernet technology you are using in that network, which, like I said, all of these cables transfer data at different speeds. So what I have here is a Cat5. There is also, if you look at this list right here, type of card cables. There is Cat5. This is the speed of transmission, 10 megabytes per second. So if you are going to a store to buy a Cat5 cable, know that that is the speed that cable is going to transmit data. Cat6 is transmitting at 1 gigabyte to 10 gigabytes per second. That is a very, very fast cable. So if your Ethernet network, your Ethernet environment uses Cat5 cables, then expect this kind of data transfer speeds in that network. But if that network is using Cat6, it's going to be faster. And anything within this number will fall under 1000 base T Ethernet technology. So base 1000 base T, 10 base T, 100 base T, they determine the transfer speeds based on all these connectors. So that is it. So let me come back to network interface card. Like I said, you can call it the network controller. You can call it the network adapter. You can call it the Ethernet card. And what does it do? It is used to connect your system to the local area network. Otherwise, it is used to connect your system to the internet. So if your NIC is not working or your internet controller is not working, forget it. Your machine will not connect to the internet. So you have to go troubleshoot, make sure your NIC is enabled. And if it's enabled and not still working, then the controller itself might be bad. So most computers have the NIC built in as part of the motherboard. And I showed you this picture. I showed you a picture. This is the motherboard. So this is part of the motherboard. So you connect through this port. This is part of the motherboard. And I went further to say, so they are wired NICs, and they use wired NICs use an RJ45 port. We know what an RJ45 port is, right? This is the RJ45 port, and this is the NIC itself. So this is the port, which is the entrance to the NIC. So this port right here, you can call it an Ethernet port. You can call it an RJ45 port. They mean the same thing. And yeah, so that is it for that, for NICs. So
excuse me. So
yes,
how
sir.
does it for computers, for example, like mine that doesn't have an RJ45 port? How does the NIC work then? The NIC.
Yeah, so you have a wireless NIC. So NICs can be wired. My NIC on my machine has 2 functionalities. It can function as a wired NIC and as a wireless NIC. Wireless NICs will connect straight to Wi-Fi, connect to the internet using Wi-Fi. Wired NICs will use the cable. So mine, I can use this cable, and I can also use a Wi-Fi connection. So you are connecting to the internet right now because your NIC is a wireless NIC, because you don't have an RJ45 port. So that is it.
So therefore, all cell phones have wireless connectivity in them.
Yes, exactly. You are thinking like an IT pro. So let's talk about the range of an Ethernet connection. So the maximum range of Ethernet is 100 meters. If you want to go above 100 meters, you need a device known as a repeater, otherwise known as a signal booster, otherwise known as a range extender. That's what you can use to extend your Ethernet range because it's only 100 meters. And then you need to understand the mode, the medium and the mode of Ethernet data transmission. Of course, the medium is through copper wires. If I split this cable, I'm going to see copper wires in it, right? So that's the medium of data transmission. The data flows through the copper wires in this cable. And the mode of data transmission is electrical signals. So it's not going to shock me because it's like 5 volts. Very, very low. You might not even feel it, you know. So, but it's actually electrical signals that is going through the cable. So that is it for Cat cables. No, you have Cat 5, Cat 5E, and Cat 6. They transfer at different speeds and they use different Ethernet technologies. Okay. Now let's go to Wi-Fi. And in the document I sent to you a couple of days back, Wi-Fi actually stands for wireless fidelity. Wireless fidelity. You can also refer to it as WLAN. WLAN stands for wireless local area network. So in your home right now, if you are using Wi-Fi, you're actually using WLAN. You are in your local area network and you are using a wireless connection, which means you are in a WLAN. Does that make sense? So if I ask you tomorrow, what is a WLAN? Don't tell me you don't know. You are in your local area network and you are using Wi-Fi. So the W stands for Wi-Fi, the LAN stands for local area network. So that's what WLAN means. So Wi-Fi also has its own medium and mode of data transmission. The medium and mode of Wi-Fi technology is radio waves. So you're able to connect devices through Wi-Fi because your router is actually sending out radio waves. You cannot see it because human beings can't see radio waves with their naked eyes. But there are devices that if you bring at home at night, you'll be able to see the radio waves coming out of your router. So that is the medium of Wi-Fi technology, radio waves. These are interview questions, guys. What is the range of Wi-Fi? A Wi-Fi connection will not go more than 32 meters. It will not pass 32 meters, guys. Take note. And these are WLAN technologies too, and their own speeds. So all of these will be determined by the type of router that you have at home. If you have a router that is 802.11b, this is the type of speed that you're going to be getting. 802.11b is kind of old. 11H is kind of old. These two are currently being used right now. The 802.11n transmits data at 60 megabytes per second, and the 802.11ac. At most workplaces, these are the kind of wireless technology you find. 802.11ac, transmitting data at 3 gigabytes per second. That's super fast. Okay, let's talk about the fourth technology. So we've talked about Wi-Fi technology, right? We've talked about Ethernet technology. We've talked about Ethernet. We talked about Ethernet technology. We talked about Wi-Fi technology. Now let's talk about fiber optic technology. Fiber optic technology is the fastest means of transmitting internet. There is something called fiber optic cables. Let me just show you what they look like. Yeah, these are fiber cables right here. They are very thin. I like this. I like this one. So these are the fiber cables. This is the fiber cable, and these are the threads in the cable. They are as thin as a hair, like a hair strand. Even though you look at them in this picture and they look like they are big, they actually look like a hair strand when you open up a fiber optic cable. So that is what a fiber optic cable looks like. And fiber is the fastest means to transmit internet, the fastest. So, and it's used to transmit data over long distances. So you want to connect the United States to, say, the United Kingdom, you're going to be using fiber optic technology. You're not going to be using Wi-Fi. Wi-Fi's range is 32 meters. Remember, Wi-Fi is 32 meters. So let me just ask a question to my brother who was in Sweden, Jarvis. How do you think Sweden is connected to the US? What kind of technology do you think is being used?
It's kind of wireless.
Cannot be wireless. I told you wireless doesn't pass 32 meters. Wireless, I told you.
As a fiber optic.
Fiber optic.
Maximum range of Wi-Fi is 32 meters, so it cannot be Wi-Fi. All right, someone needs to mute. I think it's Bismarck. Okay, now to connect continents, you have to use fiber optic technology. So you might ask, okay, so how is Sweden connected to the US, right? And I'll tell you this, most of you didn't know. The fiber cables actually run from Europe to the US, going under the ocean and connecting to the United States. It goes under the ocean. You might not have known, so know today. That's how continents are interconnected. You have fiber optic cables that actually go under the ocean. You can go on YouTube and you watch how continents are connected using fiber optic technology. You will see a ship actually going across the ocean and running the fiber cable on the ocean bed. And that is why I'm able to talk to you right now, Jarvis, even though you're in Europe, because we are using fiber optic technology. And look at the maximum speed, 100 terabytes per second. Is lightning fast. And the maximum range is 200 kilometers. And then the medium of transmission is glass. So there's actually glass within that cable that I showed you, the picture of the fiber optic cable. You have glass in between. And then within the glass, it uses light pulses as the mode of transmission. And if light takes how many seconds from the sun to get on Earth, that tells you if you are sending light from Europe to the US, it's going to be shorter, right? It goes very fast. Light is one of the fastest things that we know. Speed of light, there's nothing that is faster than the speed of light, right? Yeah, so fiber optic technology uses light pulses to transmit data as the mode of transmission. We're about to finish, guys.
You said 200 kilometers, but on there it wrote 20 kilometers.
So after every 20 kilometers, it connects to some other fiber and it keeps extending. They keep extending it. Every 20 meters, they keep extending it. So we are about, I know we are 3 minutes past time, but we're about to be done. I just need to finish these few other items and I'll go very fast. Let's talk about a modem. A modem is simply a device that receives network connectivity from your ISP. Remember what is an ISP? Your ISP is your internet service provider. It's the company that provides internet. Comcast, Verizon, whoever you're calling for internet is your internet service provider known as your ISP. So when your ISP comes to your home to connect your internet, they're gonna bring a box. There should be a box somewhere in your house, a little box, right? Somewhere lying around. That is known as a modem. In some cases, you might have two boxes, two little boxes. In some cases, you might have one. How many do you have, Faith? You have one. Who has 2? Is there anybody with 2? Okay, Bila has 2. Who else got 2? Jonathan, you're not answering. Everybody should be answering. This is a general question for the class.
Sir, I have 1.
Okay. Emeka, how many do you have?
I also have 1.
Okay, nice. Some people have 1, some people have 2. Let me explain to you 1 versus 2. If you normally you should have 2, but because they don't want to crowd your houses with a lot of devices, you will have 1. The modem actually receives the internet signal from your ISP. And then you have next to the second device you have, Faith, is a router. So if you have 2 at home, you have a modem. Your first device is a modem. Your modem is what brings the internet into your house. And then your router connects to the modem. And then your router is going to take the internet signal and broadcast it wirelessly or through a wired connection. Your router does not route, it's not, internet connection doesn't come to your house through the router. It comes through the modem. So if you have 1 device, then it is a modem/router combo. Take note of that. So if you have 1 device, it is actually 2 devices that have been joined to become 1. It is doing modem work and is doing routing too. So you either have 2 devices, modem is bringing the signal and giving it to your router. And then your router is taking that signal and transforming the signal. So what your modem does, it brings analog signals. Your computer will not understand analog signals. So, sorry, your ISP is going to send analog signals to you, right? Through your modem. And your modem is actually connected to the wall. There should be an opening in the wall that the box at your house is wired to. That connection on the wall connects straight to your internet service provider. So your modem receives analog signals from your ISP. It can be through phone lines, through optical fiber connection. I haven't seen optical fiber in any home because it's very expensive. Or through coaxial cable. This is the one that you will see is like the cable. It actually connects to the modem. And your modem is gonna convert that analog signal into a digital signal. If your modem does not convert it, your router is not gonna understand it. So the modem converts the analog into digital for your router to be able to understand. And while your router understands the digital signal, it takes the signal and then broadcasts it to your network for everybody to be able to connect. That is what a router, that's what a modem is. But if you have a modem router combo, that is all one piece, the modem is still going to be doing the same thing. It will bring the signal in, the analog signal, convert it into digital signal. Then the router part of that combo is going to take that signal and send it out so you can connect to the internet. And just know there are 3 types of modems: cable modems, DSL modems, and dial-up modems. Okay, that is it for modems. Router is a network device that distributes or route your modem to the devices on your network, like I just explained. It takes the analog traffics and your modem converts the analog traffic to digital. Your router takes digital traffic and routes it to all the devices in your network so that the devices can connect wirelessly or through a wired connection. Your router also does something called network address translation. Guys, this is very important. NAT, network address translation. I put it in caps, and let me explain what NAT is. I'm also very watchful of the time. So NAT, this is what happens. Every time you connect to the internet, your router uses your router's IP address to connect to the internet. And let's say you're trying to go to facebook.com. You type facebook.com on a browser. Your laptop, whichever device you are using to communicate with Facebook, for example, your laptop is gonna connect to your router Remember, your laptop is a device on its own. It has its own IP address. But addresses within your network or within your LAN are known as internal IP addresses. IP addresses out of your network on the internet are known as external IPs, otherwise known as public IPs. You cannot, guys, write this somewhere. You cannot use an internal IP address and communicate with a device on the internet. It will never work. Pay attention to what I'm saying. You cannot use an internal IP address and connect to the internet. So this is where NAT is going to come in. So network address translation, it is built in your router. So when you have a device, internal device in your network that wants to connect out of your network, the IP address of that machine you are using is gonna talk to the NAT, the network address translation of your router. What is NAT gonna do? NAT is gonna take your IP address, store it, use the public address of your router to connect to the internet. Every router comes with one public IP address. You cannot own more than one public IP address. And to check your IP address, please, your public IP address, go to the internet, open google.com, type, what is my IP? It's gonna tell you your IP. This is your public IP address. Everybody should do that. That is your public IP address. If I want to talk to your network, I have to know your public IP address. And you have just one public IP address. Now you might ask me, oh, DHCP, I just said earlier that DHCP assigns IP addresses. How come am I saying you only have one public IP address? Like I said, if you want to communicate out of your network, your router uses your router's public IP address to make any connection. And when the reply to whatever you want to do to the internet comes, it's going to come back to your router. And then your router is going to talk to NAT that, okay, this device within your network requested facebook.com. We have used our public IP to talk to the Facebook's public IP. And this is the reply. Send it back to that local IP that requested it. Do you guys understand? Do I make sense, or should I repeat? So you only have one public IP address. So everybody should check their IP address. There's another website, IP Chicken, which we use a lot in the IT world, IP Chicken. So you can go to IP Chicken. You open up IP Chicken. You know, it's just going to tell you your current external address. This address is never going to change, guys. Your external address is what your ISP allocates to you. And you have no control over your external IP address, no control. If you want to own this address permanently, you need to call your ISP and they'll give you a huge bill. They can charge you like $5,000 for you to be able to own your external IP address. So take note of that. That is your external IP. I repeat, if you want to connect to the internet, so Emeka, you're sitting on your laptop right now, your laptop has an internal IP because it is local in your network. Remember, we talked about a LAN. Every device in a LAN is local. Anything out of your LAN is public. So devices within your LAN are private devices. That is why I cannot sit from my network and talk to a device in your network. Because you cannot be in a LAN and talk to a device in another LAN. It's not possible. So devices within your LAN have IP addresses. But if you are sitting on your laptop has a private IP. You want to connect to the internet, you want to go to facebook.com, you type facebook.com on a browser. The IP address of the machine you're using is going to talk to your router. And then network address translation is going to happen. NAT is going to take your address and store it, and then use the public IP address of your router and connect to the internet. get the information from the internet you need, bring it back to your router, and then NAT is gonna say, okay, this information is for this internal IP. This is the machine or the device that needed it, and then it's gonna send it to that specific device. That's how communication happens. So internal addresses are not publicly routable. Only public addresses are routable. Take note of that. It's very, very important in networking. If there is anything you should understand in this networking class, is what I'm explaining now. Very, very important. And the reason why network address translation was introduced is because devices at some point, they started producing more devices than available IP addresses. So they are like, if we keep on producing more devices and we don't have IP addresses to allocate to these devices, because every IP address needs to be unique, at some point we're gonna run out of IP addresses. So let's just keep everything local and make it such that each time any device needs to go to the internet, it's gonna use the public IP of that network, connect to the internet, get whatever it needs, and come back to the network and deliver it internally to that internal address. So that's how routing works in the internet. So we are almost done, guys. I know I've gone 15 minutes above. A switch simply connects network devices together. That's all a switch does. But a switch is very important and it's very smart. You can configure switches to do wonderful things. So let me show you a picture of a switch. And a switch has multiple ports behind because it is used to connect different devices. Every device in a network that is connected with a wired connection connects to a switch. This is what switches look like. Let me go to images. So these are all switches. You see they have a lot of ports behind. So this is like, and they are expensive. Look at the price of this one, 4,250. Switches are not cheap. So in your IT environment, you're gonna see a lot of switches. So any machine that is connected with a network cable or an Ethernet cable must be connected to a switch. The switch in turn is connected to a router. So the signal, the internet signal goes from a router to a switch, a backbone switch. The switch might have around 50 to 100 ports. And then you see a lot of connections coming out from the switch and going to various devices. So the connection is gonna come out from the switch and then they're gonna wire it in the building through the walls, right? And you see in your cubicle at work, you just see the connector, the port in the wall, and you can just connect your laptop there. But that connection is wired through the wall to a switch somewhere in the building where you don't know where it is. But as an IT personnel, it's gonna be in the server room. So if you go into a server room, you're gonna see all these connections that are connected to a switch. You know, so that's what switches do. And switches are actually smart. The switch has a console where you can actually remote into the switch and configure the switch to be able to take traffic from this person and send to this person. You can configure the switch to close some of these ports, to disable some of these ports and enable them. So if you only want to use like 4 ports here, you can log into this switch, connect the switch, log into the switch, and configure the switch to use just like 5 or 10 ports if you want. So switches are very, very smart devices. So that's what switches do. And let's talk about this one, a wireless access point. It is a device that creates a wireless local network, usually in an office or a building. It connects a wired router or switch and projects a Wi-Fi signal to a designated area. So think of a wireless access point as an extender to your Wi-Fi connection. So you have a house, you have first floor, second floor. The third floor of the house is not receiving internet. What do you need to do? You don't need to go buy an extra router. You just need to buy an access point. Put on the third floor, connect the access point to the router, and the access point is gonna extend that wireless connection. So you only need one router, but you can have like 5 different access points. So if you're having internet problems at home, all you need to do is to go buy an access point, and it's plug and play. You don't need to configure an access point. You buy an access point, buy a card cable, plug it to your router, take it to the area of the building where it's not receiving Wi-Fi, and you're gonna have full Wi-Fi functionality in that area. That's all what a wireless access point does, and that is it. And unique network identifiers. A host name is simply a unique name for every machine. At work, every machine will have a host name, and your company will decide how to name machines. You cannot find a machine that will not have a name. Every machine will have a name at work. An IP address, and I told you an IP address is a unique address that every machine has. Without an IP address, you cannot connect your machine to the network. Every machine has an IP address. It's like an SS number. IP addresses are assigned by DHCP. You can also manually assign an IP address to a machine. Take note of that. At work, you have machines that receive IP addresses from DHCP dynamically. It means connect to the Wi-Fi, DHCP will send you an IP address. But servers don't receive IP addresses from DHCP. No, because like I said, your IP address can change. DHCP is leasing that IP address to you. So if you get your IP address through DHCP for a server and DHCP changes that IP address and you're working from home, you'll not be able to connect to that server. Does that make sense? So when it comes to servers will have permanent IP addresses. So you actually go into the device and you configure a permanent IP address. Okay, let me show you something. If you come to your machine, everybody should pay attention right now because I want you guys to do this when the class is done. You come right here where at the bottom of your machine where you have your internet signal. You can click there. Sorry, right click where you have your Wi-Fi connection in your machine. And then you go to network and internet settings. Otherwise, you can type it right here if you like. I don't know if it's gonna show up here. Yeah, you can go directly to Ethernet settings if you want to go if you want to search it here. But the easy way to do it, right click on your signal, select open network and internet settings. Now I want you to watch very well. What I'm doing now is important. What does it say here? You see your laptop, your Wi-Fi. This is the outside wall. I want you to come right here. If you click on change connection properties, if you're not having internet connection, your internet connection, this might be shut off. If I turn this off, I'm gonna lose connection right now. And this actually helps you get internet connection when you take your computer out of your home and you come back, your machine just automatically connects to the internet. Who's experienced that? You take your laptop out, you come in, it just connects automatically. You don't need to enter the Wi-Fi name and password. It's because this button is on. If it's off, you'll be entering the username and password for the Wi-Fi connection every time. So you want to make sure this is always on. Your network profile, you don't want to expose your machine to the internet. Somebody might hack it. Make sure it always says private. And then in the next class, I'll tell you what a firewall is and how to configure firewall settings. So I just wanted to show you that in the first place, right? And then keep scrolling down. Now you're gonna see, we talked about MAC addresses. This is how you check your MAC address. This is your MAC address right here. This is my MAC address for this machine. Every machine will have a unique MAC address. This is my MAC address. This is the driver that my machine uses. So if I want to update my driver, I'm looking for this driver for 22.10, yours is going to be different. And there are two types of IP addresses, guys. You have IPv4 and IPv6. This is your IPv6 address, and this is your IPv4 address. So this is the IP. At this point, I only want you to worry about your IPv4. Don't worry about IPv6. So this is your IPv4 address. And again, this is your internal address. This is the address that DHCP assigned to this computer I'm using. It is different from your public address that I showed you. You only have one public address, and that public address is on the router. Your public address is not on your computer, it's on your router. Take note of that. Every machine you connect to your network is assigned an IP address by DHCP. This is the IP address of this machine. 172.16.21.136. It's always going to be separated by dots. It cannot be more than this. It can be 123, 123, 123, 123. It cannot be more than 12 digits. It can be 1.1.1.1. It can be 1.15.20. It can never be more than 12 digits. So when next week, Charles is going to explain IP addresses to you in detail, so you understand what they are and how they work. But this is my IP address. So check, you're going to know what your IP address is. This is your network bandwidth. Your network bandwidth. My bandwidth is 5 gigahertz. That's the amount of data that can go through my network. If your bandwidth is small and you are trying to force a lot of data through that network, your internet connection is going to be slow. So bandwidth is also important in determining the speed of your connection. And remember, I showed you under Ethernet technology, I showed you 802.11. So my router is 802.11 AC. So check yours. In this document, I showed you here the different types of, right here, the Ethernet technologies, 802, this is the amount of speed that I'm getting based on the router that I have at home. So check yours. So that's, after understanding this, you can be able to determine why your internet connection is slow. If you are using a router that is 802.11b, its transmission speed is 110 megs, that is a slow internet connection. And you'll be able to say, oh, I want to upgrade this. I probably want an 802.11 AC. So when you use this terminology, you should at least know what they are, and you should be able to come here and check what you have at home to be able to determine the kind of internet speed you are having. Okay. Come right here, let's scroll up. It says IP assignment. What do I have here? DHCP, automatic. What does this mean? It means DHCP is sending me IP addresses automatically. It's automatic. I'm not telling DHCP, oh, I need this IP address. The moment I connect to any device to the network, DHCP will send an IP address to that device automatically. However, I can edit it and change DHCP from automatic to manual. And when I do manual, I have to decide the IP address that I want for that machine. And that is how servers are configured. You need to give a static IP address to a server. The IP address of a server should not come from DHCP, because DHCP can take that IP at any time. That server, that IP can change. And if that IP changes, you will not be able to connect to that server. Imagine you are trying to connect to Facebook right now and you cannot connect because Facebook decided to use a dynamic IP and DHCP changed that IP. A lot of people will go offline, they'll not be able to connect. So that's why you want to make sure you have a manual configuration of IP addresses for your servers so that they never change, so that people are always able to connect to that IP. Okay. So, oh, I closed this, sorry. So let's go back here. Let me show you some more stuff. So if I click on Ethernet right here on the left, right? I want to see my adapter. This is how you see, I told you guys about enabling and disabling your network adapter, right? So click on Ethernet right here. Ethernet, you want to see your adapter. Now, you can click on change adapter options. And it's going to open this. So these are all Ethernet adapters. These are all NICs on my machine. These are all NICs. You see the ones that are X'd out? Those are NICs that are disabled. I have a virtual box running right now. The NIC of that virtual box is enabled. This is what you can see it right here. It says enable. Because I have a virtual box that is running. The virtual box is a computer. It also needs a NIC, so you can get an IP address. So the network interface card on that virtual box is enabled. This is my connection right here. This is my Wi-Fi. It's going to show your home Wi-Fi. So this is the NIC of my physical machine, the machine that I'm on right now, my laptop. This is the NIC of my laptop. It tells me here Wi-Fi. This is the NIC. If I double click on that, come right here, look at the details. This is the speed I'm getting. This is my internet speed right now. 780 megabytes per second. This is the duration. So if your internet speed is lagging, you can come check your NIC, what is happening. If you are getting like 500 and below, then there's something wrong with your NIC. So you should get at least 650 and up. Okay. So now you can look at how your NIC is communicating. It's receiving data and it's sending out data. Look, data is coming in bytes. Guys, look at this. Data is coming in, received. This is what is being received. And this is what is being sent out. So your NIC is always in communication because your machine is connected to the internet. It's communicating with other devices. So data is coming in and out. So you can see this. If you go to your NIC and you don't see your computer communicating, something is wrong. And I told you, if your NIC, this is where you can disable a NIC to a computer. If you get a hack, your machine is hacked, the first thing you want to do, go in and disable your NIC. That kicks it cuts off the internet connection and kicks the hacker out. So if I click disable right now, it's going to cut my internet connection. It's going to drop this call. So I told you, when you are troubleshooting a NIC, this way, if a NIC is disabled, it will show here disabled. So mine is enabled now. You can see everything is in green and I'm able to communicate. If I click disable, it's going to disable it. If it's not enabled, you can come enable it here. This is where you enable your NIC. Okay. If I click on properties, watch this. This box is going to open up. Scroll all the way down. I want you to go to IPv4. Click on IPv4, TCP IPv4, right? And click on properties. Look at what it says. Obtain an IP address automatically. What does this tell you? It means my machine is getting IP address from DHCP. If I don't want this machine to get an IP address from DHCP, I want to do a manual configuration so my IP address does not change. I'll come here, use the following IP address. I click. If I know the IP address I want to use, I actually put the IP address here. So 192.168.20. This is just an example. Don't take this as a literal. Take this literally. It's not an IP address that I actually want to assign. It's a .10. So I want to assign this IP address to my machine. I'll do this. I'll also assign a subnet mask, which is 255. You click on subnet mask, it's just going to assign it to you. You don't even need to worry about subnet mask. Charles is going to explain to you what the 255.255.255.0 mean. Default gateway, I have to put in my default gateway. And default gateway is the IP address of your router. Your router is a computer too, so it has its own IP address. Don't confuse this default gateway address with your public IP address is different. Remember, every device in the network has an IP address. Your router is also a device. It has its own IP address. So you're gonna put your router's IP address right here, which is the default gateway. Default gateway actually means it is a gateway through which data leaves your network and goes to the internet. And it comes when you're having data that is coming into your network, it comes through that gateway. So every network has one default gateway. So that's how data comes in and out of your network through your default gateway. So if I configure all of this, and then I'm gonna click OK. When I click OK, henceforth my IP address is gonna be this. It's never gonna change because I've done a manual configuration. I'm not using DHCP. That's how you do it. Okay. And we are almost done. What else am I gonna touch? That is it. What else do I need to explain here? We've talked about network protocols, network ports. So I told you there are 65,536 ports. I told you that, right? So you can read this. There's nothing to emphasize on that. I've explained GCP to you. The last thing I'll explain to you is DNS, and then we're gonna go. DNS stands for domain name system. DNS is very important. What does DNS do? DNS takes an IP address and converts it to a domain name for you to be able to connect to a server. Here's what you need to know, guys. Computers communicate by IP addresses. They don't communicate by names. So if I want to talk to Emeka's computer, I have to know Emeka's IP address. That is your public IP address. So Emeka, if you want to talk to Facebook, you need to know Facebook's IP address. Remember the last time we used the command prompt and we pinged Facebook. How were we able to ping Facebook without knowing Facebook's IP address? Because we're able to do facebook.com. This facebook.com domain name is tied to an IP address. So humans understand names like this. Computers understand numbers. Computers don't understand this. So every server or every website will have an IP address. Every server will have an IP address, and a domain name will be tied to an IP address. And it is being done by DNS. So think of DNS as the telephone book. Remember back when we were still using telephone books? If I want to call Emeka, I have to look at his name, his address, and then the phone number. That's the same thing Facebook does. DNS does. So if I type facebook.com, DNS will say, okay, who is facebook.com? What IP address is tied to facebook.com? So DNS has a query. It's a database of domain names and IP addresses. So DNS will query the DNS server to find facebook.com and then get the IP address of Facebook. Bring that IP address back to your machine before your machine can connect to Facebook. That's what happens every time we type facebook.com, for example. I type facebook.com. How am I connecting to Facebook? DNS is doing it for me right here. DNS is at work. DNS is working right now. I'm able to see the Facebook page because of DNS. So DNS will take this page, this URL or domain name, query its database to see if it's going to find the IP address of Facebook. When it gets the IP address, it's going to bring the IP address and give it to my web browser. And then my web browser will take that IP address and connect to the Facebook server. And Facebook is going to serve this page to me. That's what happens in the background. Because like I said, computers communicate by IP addresses. Facebook.com, your computer does not understand this. To your computer, this is gibberish. They don't understand what this is. They don't understand that. What your computer will be interested in is the IP address of Facebook. So let's do something. So let's ping facebook.com, right? So let me do a ping on facebook.com. It's going to give me the Facebook's IP. Ping facebook.com. Okay, it's going to ping 4 times. This is the IP address of Facebook. 69, guys, memorize it with me. 69.171.250.75. Let's go to a browser and let's type that IP. What is it again? Go ahead and give it to me. 69 dot what?
171
dot
250. I can't remember the rest.
Okay, let me open it again.
Dot 35.
69.171.250.35. 250.35. Let's press enter. What happened? Facebook.com. So that is what computers understand. They don't understand this thing right here. The computer doesn't understand. It understands the IP. Computers communicate by IP addresses. Because we are humans, we cannot memorize all these IPs. I cannot know 192.168.1.5. That is Amazon's IP. Facebook's IP. How many IPs can you memorize? It's impossible. But you can memorize Amazon.com, Facebook.com, Yahoo.com, Emeka.com, Faith.com. You can all memorize that. So that's where DNS comes into play. DNS will say, okay, I want to be the service to tie the domain name to an IP address. So each time you type facebook.com, DNS will look at the phone book. You do a query in their database and say, the IP address of facebook.com is 171. And it's going to serve it to your web browser. Your web browser will take that IP address and be able to communicate with the Facebook server. And that's why you're able to get the Facebook. That is what DNS is. And that's where we end today.
No, so it's not ended. Please, I've got like 3 confusion. I don't know whether you'll be able to spare me. You know, a great man said apparently that one knowledge builds on another. As you build me this knowledge, it's brought confusion in other areas. Okay. I would not like to go deep into what you talked about optical fiber technology because it's a little bit off the scope, but I'll meet you outside. I'll discuss that more elaborately.
Okay.
That notwithstanding, just to dive straight into it, you said Facebook, that the Facebook IP that we used, we typed Facebook, that is the fully qualified domain name, as you said, on that URL. Then we searched it.
The fully qualified domain name is facebook.com or www.facebook.com.
Yeah,
That's the
all right.
fully qualified domain name.
Okay, let's continue from there. That as we typed that fully qualified domain name, it was the DNS that searched
the DNS database.
Yes.
So here's the thing to know about DNS. DNS has databases all around the world.
No, I've understood you that one very well. The point I want to ask is it that unique IP address for Facebook that is unique for every Facebook, or is it that particular one for the closest data center for?
Yes. Okay, here's the thing. Facebook, as a multimedia company, they're not just going to have one IP address. They'll probably have like 4 or 5 IP addresses for their website. They call, in networking, that is something called virtual hosting. Virtual hosting means you can have one website have about 5 different IP addresses. But if you send traffic, it's going to go to facebook.com, no matter the IP address that is being provided to you.
Thank you very much. Thank you. Yeah. Let me not go far.
So the thing to know about DNS is the most important thing with internet functionality is DNS. If DNS does not exist, the internet doesn't exist. What holds the internet together is DNS. Otherwise, Emeka, you're going to be memorizing 100 IP addresses. So that is, DNS has made everything easy for us because DNS translates domain names to IP addresses, and it also translates IP addresses back to domain names. So you might ask the question, okay, when I type facebook.com, where is my DNS server? I would have expected somebody to ask that. Your DNS server is also embedded in your router. So your router is a DNS server, it's a DHCP server, and it's also a firewall. Charles will tell you guys about firewalls. So your router does a lot of functionality. But at work, you're gonna have separate devices. You're gonna have a physical device that is a firewall. You're gonna have a separate DNS server. You're gonna have a separate DHCP server. They're not gonna be everything combined in your router. It is done this way because we are private consumers, right? We are not using, we don't need a DHCP server, a standalone DHCP server in our houses. So your ISP will just squeeze everything and configure it in your router. But at work, you're gonna have a separate server that is doing DHCP, a separate server that is doing DNS, a separate server that is doing email services, a separate server that is doing firewalling. You know, so that is it for DNS. So let me explain one more time. DNS is like the telephone book of the internet. It translates domain names to IP addresses and translates IP addresses back to domain names before you can connect to any website out there. If there's no DNS, forget it. Forget it. So where are the DNS servers? If you are doing a query, let's say you are visiting a website, you've never been to that website before, and you type, say, ola.com, that's the very first time you are typing ola.com on a web browser. If ola.com actually exists, DNS is going to do the query. So the first place DNS is going to check is the DNS server on your router. If you've ever visited ola.com, it's going to be saved somewhere in your router, and it's just going to get it from there. If you've never been there, DNS is going to check with your ISP, the internet service provider. It will check with their own DNS server if they have ola.com. If your ISP doesn't have ola.com, your ISP's DNS server will send it to one of the global DNS servers known as the root DNS servers. They are scattered all over the US. It's going to go to the root DNS server. It's going to check that server. If it's not there, the server is going to escalate it to the next level server until it finds it. The good thing is this thing happens so fast that you don't even realize it as the consumer. It happens so fast. All you care about is that page to load. You don't care about what is happening in the background. But that's what actually happens in the background. DNS will work until it finds that IP. When it gets the IP, it's going to return it to your web browser, and your web browser is going to make the connection to that server for you to be able to see that web page. Any other connection? Sorry, I'm even tired. Any other question? We are all tired, right? Networking is interesting. Don't you find it interesting, guys?
Can you repeat that? So you said a DNS first. It does the query on your router.
Please read about DHCP. Read about DNS. How DHCP works. How DNS works. That should be our homework today. Please. I think the last thing I'll show you. I promise this is the last. The last. I have to do it. How to check your IP address. I showed you how to check your IP address by going into your network configuration card to your NIC, right? That is one way to check your IP. Another way, which is the most fastest way to check your IP, which is the most common way, is to use the command line. We all know how to open the command line. You open the command line and you type IP config. And depending on whether you're connected. Oh, sorry. I apologize. So guys, I promise this is the last thing I'm showing you. I know we are all tired. So at work, you have to, one of your duties, you'll be checking IP addresses, making sure devices have IP addresses. What is the IP of this machine? To check your external IP. I told you, you only have one external IP. That is on your router. You have nothing to do with your external IP. You can go to a web browser and you type, what is my IP? It's gonna tell you your external IP. You can go to IP Chicken. It's gonna tell you your external IP. But I'm talking about your internal IP, the IP address of the device you are using. That IP address is coming from DHCP. How do you check that IP? I showed you the first way by accessing your network interface card and checking in that way. The second way is to open the command prompt and type in this command, ipconfig. When you type this command, it's going to display a lot of information. It's going to list all the adapters that you have on your machine. I have different adapters on my machine. I showed you my VirtualBox adapter. It's going to show you your wired adapter and your wireless adapter. So you want to check how are you connected to that computer. Are you connected through Wi-Fi or through a wired connection? If you are connected through Wi-Fi, you are looking for your wireless adapter. This is my wireless adapter. Look, so you are looking for wireless LAN adapter, Wi-Fi. If you are connected through Wi-Fi, what is my IP address? I told you are looking for IPv4. What is my IP address? This is it right here. 172.16.21.136. Everyone should check their IPs and put it on Slack right now, please. And then we're gonna end. Check your IP and Slack it in the general channel. And I told you about default gateway, right? Which is the main entry point into your network. And your router is actually your default gateway. So the default gateway of your network is the IP address of your router. So this is the IP address of my router, which is my default gateway. So if you are connected if you are not connected with Wi-Fi, then you are looking for Ethernet. There's no IP address here when I look at Ethernet. Why? Who can tell me why?
Because it looks like you are connected to the Wi-Fi.
Exactly. So if I was connected using a wired connection, then I'll be looking at Ethernet Ethernet adapter. But I don't have any IP here. I don't have any IP here because I'm not connected with Ethernet. I'm connected with Wi-Fi. So I'm looking at my Wi-Fi adapter, and this is my IPv4 address. So how many people have posted their IPs? Keep it coming, guys. Nice work. I love this. And that is it for today. I'm going to stop recording.